right, how are we doing? It's Friday. So I still got way too many people in the house today, but I'm going to stream anyway. Way too many people. So I found that if I plug this in, the USB, it fixes the weird channel. See, this is all cursed. Like something's infecting it. I don't know what's going on there. I don't know how, man, we got to fix that somehow. Maybe we take a look at that today. But like if this ground is connected, it fixes it. This is my computer ground. So this one's going all the way back to the USB, which is connected to the table. But the power for this comes from this brick, which is the same brick that powers the scope. I don't know. Maybe we can put in my other power, my alternative power brick. Maybe that'll help solve it. I don't know. Very strange. What's up, Paloozer? Yeah, so this works perfectly fine if I plug it into the, what you call it? Oh, we need to open up YouTube for comments. Hold on, let's do YouTube VOD @BotherVOD. Get my tune module. I do all this work for YouTube, and it seems like it doesn't really go anywhere. Like we got all these thumbnails that I make for YouTube, and nobody ever sees them. My thumbnails are nothing special, but still, you know, put work into it. Anyway, how's everybody's Friday doing? How is everyone's Friday? I got a bunch of Thai food last night, and it was super duper spicy. And I paid the consequences, and I will never learn that lesson. Beers, yeah, beers on a Friday. That's actually what I am doing later today, so I'm going to have to end a little early. I have to be militant about my ending times so that I can make it out. What, weird, the Thai food thing? No, that's totally normal. That's what your body does with spicy oils. No, the ground thing, I know. We should probably, at the beginning of the stream, like when I decide to start working or I get bored of this shot, take this thing off and just verify the grounds on the Arduino, because if it's stabilized so well from an external USB ground, I mean, look at this. Burp. Actually, that might stabilize it for a while. Oh, no, there it is. The death of Smoochie. Yeah, see there, I get near the digital and it goes nuts. But then if I tap this on, I can then get near digital and it doesn't go nuts. I went a little nuts because I actually physically touched it. But see that? Now I'm near it and it's stable. So it is apparently my computer's ground is doing something. It's not really my computer's ground. I guess it does eventually get back there. It is the USB hub over here. And that's only going to get, that system's only going to get more complicated as time goes on. That's going to get worse because I'm going to be plugging in much more complicated USB stuff to it. It's going to go, I've got USB-C coming back from the computer all the way to behind the monitors, and then I'm going to have a USB-C hub, and then I guess one line from the hub is going to go to a USB 3 hub that I'll be able to, it'll be able to like migrate for the camera and the mixer, I guess. I don't know. I got to resolve all this in my head. It's too many things, and I got to figure out how I can make everything work at once, which you can't. You can't make everything work. But I have all the equipment. I have all the equipment I need to make it work. So, and the whole reason for that is so that the camera can share a USB connection with the Stream Deck XL. So I get more buttons, and I'm able to control things a little bit more fluidly in my stream. With more buttons, because more buttons is more better. The music will be back. It'll be back. It always comes back. But yeah, I got this thing done. How about that? So now these 3 buttons will change the modes. So now it's a sine LFO. Or no, it's high-low sine, and then the other channel's low-high. This one is tuning, so it goes from A0 to C4, and I may alter those notes at a later date. It's all just hard-coded into this thing. Tune C4, tune A0. Centering that text took a couple uploads. And then over here, I have my LFO and pulse. LFO/trigger. With a saw and a triangle wave. Frequency stays the same on the LFO, but the pulse changes its frequency. Finally home to watch a stream. How's it going, Chester? Yeah, this is what I've been working on in the background, is getting the screen tuned. I think what I want to do is make the top button change the overall test mode, so the whole screen will change with the top button. And to do that, I need to do stuff in the code. But we're not coding today. We're testing modules. I want to actually put this thing to use doing stuff. Oh, that didn't change. This one. Although one thing that I did want to do for a stream was figure out how to make an animation for the startup of this thing. Right now, it just sort of unceremoniously dumps itself into working. Yeah, we're doing the squiggles. Wait. Oh yeah, I plugged it into the high-low. If I go over here, we got our LFO, low frequency oscillator, and it does ±5 volts instead of 10 because most Eurorack control signals are 5 volts, is what I hear. Yeah, we've been working. So I've been working on this. We did a couple programming streams on it, and then I kind of didn't stream on the other day. What the hell day was that? This is one of the ones that starts with day. Wow, I didn't notice that this one was soldered so badly. Huh. It was on Tuesday. We did a little bit more programming, and then I was supposed to stream on Thursday, but there was people coming into the house in and out, and so it was just chaos here. So instead, I actually sat down and did some programming while ushering people around. Yeah, this one's soldered all badly. But yeah, anyway, so this thing now works, and I've got 2 modes programmed into it. I have a plan for more modes. I think what I'm going to do is I need to put this function here, screen wave set, needs to look at the like an overall mode and then change accordingly. So have you even seen the bubble windows now? I've got a little bit more diegetic looking windows, and in being an engineer, I was totally inspired and used the color white, which is boring as hell, but I decided that it would contrast the video window a little bit and kind of make it stick. I don't think I caught a stream once. This was like a couple weeks ago that I did this. So using a plugin that allows me to drop shadow and soften the edges. The new job is demanding, but that's good though, right? I mean, it keeps you occupied, right? So it's a good thing. Yeah, I've been doing a lot of like configuring around here and just trying to make this look a little bit more professional. This camera got bumped. Why did you get bumped? You're over here. That's what you're supposed to be looking. You're not supposed to see my desk. That's a violation of my privacy, or privacy if you're British. You're supposed to just barely see this, because that's where I put the dick butt. Now, what's going on? This camera's loose now. Great. Spend all my time recreating this shot. That goes there. And then this goes here. That's a little bit more like it. What's up, V-Drop guy? Yeah, this is OTT. Can you make it like a spinning gradient? I guess you'd have to, chroma key the edge and then do some kind of other picture. Yeah. I guess I could. I could make it like, animate something, but it would have to, I don't know if it would, I guess I could do the color scheme that I usually use and have some kind of I'd have to build an animation to do that. But I could definitely chroma key it out because it doesn't have any blur effects on it. And I know some streams do that. I should think about that. I don't know OBS that well. I never did streaming stuff myself. I could easily chroma key it. Yeah, GoNat will just tell you to use Sammy board. Sammy board is the one that slides stuff all over the screen, and I could definitely use it at this point because I have these boxes, and those boxes could like slide in and slide out when I change scenes. I don't want anything hindering my punchy, doing this joke, because the slower that activates, the less funny it is. So having those elaborate scenes where things slide about, I mean, it would make switching from like this one to where's the hold on, switching from this one to this one less jarring. That'd make that less jarring, but still. Give me a few minutes to get my stuff in order, but I know your presence. What is that even? I don't need to know. Yeah, these glucose levels are brought to you by Thai food, totally eliminating me last night. I guess lunch is reacting a little stronger than I thought, but it's not peaking as high as I would think. That's that window over there. Have you been doing BTS stuff? Not as much as I should have. All I did was throw that on-air light on it so far. And so I need to get back to working on it. I said I'd work on it this month. So the month there's not a lot of this month left. We've got 1 week. So next week I think is burn the subs week. Although I have not done an AutoCAD ad this month. So I think beginning of next month, if we don't do it next week, I need to do like 3 AutoCAD ads just to bolster the account and make sure that I don't lose my license. Yeah, just doing something. I know. One of the things I want to do is tear out all the wires. So that means taking the table over here, this table, getting everything off of the table, because the table's currently like locked in with all this crap on it. I've even got a project that I haven't told you guys about. I have back here this thing. This is I don't know if Chester would know anything about this. Sometimes people come in here and they know something about something that I don't know, because I'm thinking in order to get my tires off from over the garage door, I wanted to have an easy way to lower them that didn't require another person. So I bought this winch, and it's literally just a motor on a spool. I'm gonna try to very carefully resist the urge to want to upgrade this motor to something like 3-phase. But what's that? Next week a new Aesop Rock album drops. Oh, that'll be nice. Yeah, I could use some Ace Rock music. He's become a gray-haired old wizard. And then they sell these, which are the DeWalt 20-volt max battery cradles. You can 3D print these. I just decided to buy them because it was easier. So this, or 2 of these, powering this, I think I can turn that into a little garage winch that'll help me lower tires from the rafters. I'll have to put that to the test, though. I don't know if it'll ruin those batteries or not. Maybe 2 in parallel would be able to do it. 2 batteries in parallel powering it. Sounds reasonable. I don't know what kind of demand a winch has. I know that, the Titan of cold cranking, the car battery, should be able to handle that. That is something you don't know anything about that. Okay, I don't know. Sometimes car people know stuff about that. Yeah, because that motor is going to be fairly amp heavy. And those, yeah, I don't know. I'll just try it and see what heats up. Just see what gets hot and explodes. Yeah, the current draw, winch. There's an I. I mean, yeah, that's the basic principles. You could just look it up. Look up the 2 items and see how far apart they are. Probably more fun just to play it by ear. See if it explodes. Yeah, I'll do an initial setup and just see what it's like, I guess. I've been kind of sitting on it. I bought this stuff, and then yeah, I should have gotten the rope one. I don't know why I bought the metal spool. The slightly cheaper version has a rope cable instead of a metal cable, and I think the rope cable would have been better for, you know, garage use than the metal one. Those metal cables can have little frays in them that'll hurt your hands if you touch it. We could try to run some numbers in the Discord. Nah, it's fine. It's fine. I'm just gonna try it. I'm just gonna try it. Those the lithium-ion cells do have tons of current that they can provide. They're really good at doing that, providing lots and lots and lots of current. The wall adapter? Which wall adapter? You mean the flat plate battery thing? That was just from Amazon. Yeah, there are sellers that just sell those. And generally what they're used for is for Hot Wheels. So your kids' Hot Wheels, instead of taking 10 hours to charge, you can just use the 20-volt batteries, the DeWalt or whatever brand, just by wiring it, two of them in parallel in an adapter. So those adapters are all over Amazon. They come in packs. You can buy packs of like 2 or 4 and just, yeah. Man, suburban kids are spoiled, man. Got them Hot Wheels and their dads are juicing it up with 20V max batteries. But I can see them being useful in a variety of other ways and things that can take 20 volts. I have a couple battery operated tools that I would like to modify. Instead of using their proprietary battery that, you know, takes forever to charge, I wanted to use the DeWalt battery. And so I could chop off the end and glue that thing on there, and then there you go. All the new electric powered stuff is so much cooler than when we were kids. Yeah, the e-bikes, go-karts. Yeah, for us, we would get some proprietarily designed shaped piece of plastic. There would be like a NiCad battery in there. So you'd go out, you'd use your cool RC car. Yeah, it has tank treads, let's go. And 5 minutes later, it would go blah, 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 dead. And so you'd be like, oh no. So you go back in and then you charge, sorry, I'm snoozing a Windows alert. Go back in and then you would plug it into the charger and go, all right, we're gonna seize the day. It's a nice day. I'm gonna mess around with my RC car. 4 hours. 4 hours later, it would have a full charge, and you would get another 10 to 20 minutes of actual use. Coworker gave me their dead electric scooter, had 250 watt 3-phase motor in it. My buddy with the free cycle stuff gave me this electric scooter that I then gave to my brother. And I probably should have kept the electric scooter. It would have been fun or funny. I don't know. I'm like a round human being. I'm pretty large. I don't think the electric scooter would have been a good look for me. I don't have anywhere to go that's safe for an electric scooter either. It would have been funny to get it to charge, but I think it was a little bit more of a liability, and I'm kind of nervous because I gave it to my brother. Hopefully he's disposed of it by now, because it's certainly, I wouldn't feel safe with that in my house. It's this giant battery with a lowest bidder style battery protection system on it. So, nah. And that was in the era when all those scooters were causing house fires. So, cool. 30 18650s. Holy. Yeah, what could I have done with that? I don't know. I always wanted to make one of those like mutant Burning Man bikes, but it turns out dead bikes for that very reason are very difficult to obtain. Dead bicycles, that is. I would have loved to put some kind of a 3-phase motor and you know, have kind of a mutant vehicle. Although I never went back to Burning Man. It was too expensive, too much hassle, too difficult to get my diabetic ass there and alive for a week. If I made a little bit more money in my career, I probably would have done that more. But I never had space for a welder and all that stuff. Although the one place in Falls Church did have enough space, and during that time is when I had that Porsche 944 that I never got running. 944 is an interesting one too. Well, at least nowadays, I don't know if that's still the case. Hertz Rental offloaded a bunch of their inventory, so you could get a white Tesla for very cheap for a little while. I don't know if that's the case anymore, but you know, with a big rental car place offloading all their cars, you could get the motors and the suspension and all that stuff out of a Tesla. I would have loved to have still had either the 944 or just some other car, just to retrofit with. Because man, that stuff is it's fun. It's fun for me, me who knows kind of how to weld and fabricate. What just made a ticking noise? I heard a ticking noise over there. What's going on? Well, yeah, nobody wants to own the Teslas, I know. Hey, I don't disagree. I wish to desecrate one and put my own brain in it. We're not talking like sci-fi. I'm talking like my own controller for an electric car. Yeah, the more, because they have, from what I understand, they have a pretty nice motor. And if you two motors, pretty nice motors. So if you put them in some kind of a different shell, you can make a pretty reasonable car out of that, from what I understand. Now, again, surface level, we choose to do these DIY projects not because we think they're easy, but because we thought they were gonna be easy at the time, but they turn out to be really hard. I don't know. I'm not totally in love with my BMW station wagon. My station wagon is of the very early era of jelly beanification of all cars. We started off, in the 80s, not started in the 80s, but in the 80s and 70s, you had all of these wonderful designs of cars where everything is blocky and boxy. And then science came in and said, hey, by the way, we can save a lot on, we can get better fuel economy if we round everything. Everything gets roundified. And so for a while, cars had kind of a weight issue and they all became a little bit bulbous and round. We're getting back into actually having design in cars, but still, I love that 80s blocky, boxy car, right? BMW went through the exact same thing. The car that I have is right at the beginning of that era, before they started to actually get sort of a sense of design. And so everything on the front of my car is all rounded out, and I don't like that look. I don't like that look. The previous generation had a really iconic, interesting, more square look to it, and then the generation after it has a little bit more design in the roundness. So I'm not completely in love with my station wagon. I do like having a station wagon. It is a cloaking device for police officers. They do not see my car. It's gone. It's just background noise. Although now my car is getting old enough that it is a little bit notable. Other BMW people honk at me as they go by. Yeah, bubble boy. Bubble, bubble, bubble butt. You have 4,000 amp hour battery pack. Blast charge the headphones. Yeah, battery wear is caused by on lithium-ion cells. From what I hear, that sort of battery memory is caused by big discharges. Because if you charge and discharge a lithium-ion cell, it expands and contracts physically, and so that expansion and contraction leads to parts that crack and can't be used in the lithium cell. That's my understanding, and I don't know if that's still the science. I read that many, many years ago, and that might be subject to a little bit of iffiness. But apparently that's what causes the memory effect. After the E3639 was the last generation was really into the BMW. I do like some of the more modern stuff that they're doing, but I don't know who decided to make that grille so large. It is insane. The design of some of these BMWs. I don't know what they were thinking. I think they lost their lead designer to Kia. And so now Kia's actually look pretty reasonable, to be honest. Yeah, the internal shorts from the expansion and contraction. That's NiCad. NiCad benefits from blast charging. I don't think lithium ion operates the same way, and I could be wrong about that. Your streams are so cool. Why so few people? Is something wrong with people not finding it interesting, or with us because we're geeks? Hold on, let me get my checkbook for you here. I just need to, let me just get my checkbook and sign you a couple checks. I'll send you a sticker in the mail. Sorry, that was a paid chatter, everybody. That was a chatter that I arranged earlier. Yeah, I'll get your check in the mail. I'll let you know when your check's in the mail. I don't know why there are so few viewers. I want more viewers. I don't know. Maybe I need to do due diligence, but I freaking hate TikTok. I hate it. I hate it. I hate everything about it. I hate it. And I hate Instagram and Facebook. So I don't really do anything with those platforms. And so maybe that's why there possibly aren't people here. Yeah, in addition to the fact that we are on a gaming platform doing electronics, which makes it a little weird. But, you know, Ulo's Lab is like 400 people. So clearly I have room to grow. I could start earlier. I could start later. If I did later, that would probably work. What's up, Mythical Rock Hounding and Fossils? We the nerds. You know, doing the simulcasting to YouTube works pretty well too. I mean, there's a slow trickle of more people, including people who come in and give me nice compliments about how I don't have viewers. I gotta get rid of some of these windows, these example windows. The U8G2 library is pretty cool. Does a lot of cool stuff. Where are we? We're looking at all of my excess Arduino windows. How many do I have? This one goes away. It was a beast figuring out these waveforms. I found out that actually instead of doing weird stuff with the pulse width, because the way the pulse width works, pulse width on this thing, you can do the duration of the pulse. You can do the amplitude of the pulse. The pulse is at negative, well, it's, where is it? It's like, for some reason, hold on, I'm thinking. The pulse in the library starts offset, so that actually put it at a weird space. Did you watch any Computex? I don't know what that is, so no. But it, basically, whatever I was doing needed to get inverted, so I had to do a high instead of a low, and then the duration of the pulse was the duration of the not the pulse. Everything screwed up the math until I figured out that instead of doing all of that math, what I could do is in the audio tools, I could simply place an amplifier in the path. This revolutionized the programming because it made everything more simple. Because you can put an amplifier in there and you can just make it -1. Because the transfer function goes from -1 to +1. And if you go above that, it gets a little squirrely. The programming doesn't hold up very well. It's not actually an op amp, it is a software amp. But what this does is essentially tells the program, hey, do everything in the opposite way. So that when I physically output it from the audio chips here, it then goes into my TL072 that amplifies it up to ±10 volts. So now it works. The only thing I paid attention to was the new AMD Threadripper and GPU. You see, I don't, and again, this is something that I addressed when somebody came in here last stream on Tuesday and said, hey, Bother, what about computer thing? And it's just like, I don't know. I don't know. I don't know anything about computers. The thing is, like, what's that? Noctua is moving away from their fan roots. What are they doing now? I don't follow computer stuff. I use computers. I know computers extremely well. I know how to build computers down to, you know, computer science. But I don't keep up with that stuff, the popular stuff. I don't keep up with it. It's too much information for me. It's too much bother. And I can't afford any of it. So it's like our new card that's designed for AI. And I'm just like, I'm never going to be able to afford that. Like, why would I get one? What would I do with it? Like, It says, oh, but it's techie stuff. You know about this. I'm like, yeah, I know about it, but I know how to know about it, so I don't want to know. When I need to know, I'll know. I'll go in and I'll research and I'll say, all right, this stuff seems reasonable. Buy that, I'm out. Handle it yourself. That's sort of my attitude with that kind of stuff. I have friends who are just immersed in the computer stuff and talk about it endlessly. And they're the same way with cars, in that they're doing like heavy level oil analysis and they know exactly what's supposed to be in the oil. I'm like, it's oil. It's oil. You are driving a 330i. It is the most owned car in the world. It is not a fucking space shuttle. You do not need special oil. Like, okay, that's my attitude on that stuff. And you will find, with a more reasonablest attitude towards these things, not knowing every, I mean, I say that, and yet I know I have to know every facet of everything that I build. So my abhorrence to AI is that I need to know how things I own work. I wouldn't like to have a car if I didn't know how it worked. But so I am of the same, I'm cut of the same cloth. I can't hold my nose up at it too much, but I do find things are a little bit more pleasant when I'm not immersed in fandoms and worlds. I dip my toes in. Whatever looks interesting and useful. Appliances have been getting worse. And I would imagine now everything is on Wi-Fi. Best viewers, I want the best viewers. Here's the reason why my channel isn't popular. I didn't actually ban them, did I? Hold on, let's show that again. Oh, I can't. Oh well. So much for my plan to pay for viewers. I like how it's using... Oh, Gonad should know about this. Worst viewer here, and it flagged your comment. Oopsie doodle, I have to allow this one manually. You made yourself look like a target. They're starting to use different characters. They're using like Cyrillic and other accented letters so that the bots don't get them as quickly. Gonad has he has a bot that's literally holding a gun at his viewers, and if you say best viewers or something like that, it'll blow you away. It's like an insta-kill. Yeah, one of the things that I think we botched mostly is allowing companies to do Internet of Things, totally unregulated. Basically, Internet of Things, appliances and stuff like that, are just signing you up to tell them about your usage of their product. That's all. It's just information brokering now. And if we had done this properly, it would have communicated on something that's a little bit more open and allows us to do things like, on my phone, I could roll down the windows of my car, but I could also see whether or not I have gas, and I can see whether my dishwasher is running. That would be useful, but instead it's all private information brokering applications, and that makes me hate it completely. Things like Tasmodo, where you can actually reflash the appliance and it works on a more universal MQTT, that's the right kind of thing. Caravos Bane says, and subbed. Subbed? Gonad, you missed it. We had a viewer bot in here, and they were using non-standard characters. Here, check it out. Boss, the viewer is on stream boo. Remove the space. You have all those characters already blacklisted? Awesome. I can't think of anything more slimy than paying for viewers. And you know people are doing it when they have 300 viewers and the chat is completely dead. You cannot have 300 people on Twitch without having a constant stream of snarky comments in the chat. The new Bosch dishwashers requires an internet connection and an account to do a rinse-only cycle. I mean, that should just be a clear indication never to buy that product. You can just not buy it. At least for now, you can just not buy it. Digging the OTT Jam. Yeah, this is off of the... hold on, I'm gonna cough. This is off of Fair Children, which has a very, very creepy cover art. But it is a very good album. This is one of the ones that really, like, solidified my fandom of OTT. I know this song is called My Name Is. Oh, it's Hello, My Name Is. Yeah, Hello, My Name Is. Internet's down, time to hand wash all my dishes. That's so stupid. I hate the future. I hate it. Yeah, you were close enough to find it on YouTube. Yeah, I mean, but what I'm saying is like, man, we had a chance there for a while to make all of these places provide information. All of these things provide information that could help unify, you know, your usage of your house and maybe save you energy. That's what they always tell you. But mostly for me, it would be so that I don't flush the toilet and ruin somebody's shower. That's I wanna know if somebody or you know, to know exactly who turned on the hot water, because my ass is cold now. Like my dishwasher's sending spam. My dishwasher keeps opening up this Russian website. Yeah, the botnets that'll come out of smart homes. That's a real reason to learn how to implement and deploy a the Pi blocker. What the hell was that thing called? Why am I dumb? Why am I dumb? What it's not the Raspberry Pi thing that blocks all the stuff. Why? Wow, Pi hole. There it is. Jeez. Streaming does something to your brain, and I think it needs to be studied a little bit more. I think if we could understand what streaming does to your brain, I think maybe we could make better medicine for being dumb. There would be less dumb in the world. PF senses PF blocker? I don't know if I want to dedicate an entire Raspberry Pi to a Pi hole. I guess I could probably put that on my server, but my server's behind an intranet, so I don't know how that works. Having the entire DNS of the house going through my server. It's a better idea to have that on a Pi. It would be weaponized by the military. The literal mentats we could invent. It would be we'd make a pill that was the opposite of what streaming does to your brain. And you'd have a big glowy brain. You look like that Star Trek dude from the very first episode of TOS. Or no, yeah, TOS. Problem is, when you have a consumer on a showroom floor, you'll never learn that until you've already purchased it and are using it. It should be illegal to not have that in big bold letters permanently painted on the front side of the application itself. And the problem is, how do you, I mean, obviously, I'm not a legislator. I don't know how you would word that to make that the reality of it. If, you know, you're not going to put on a poster, you cannot wash dishes without an internet connection with this product. That's not, because maybe they even didn't know that. They just never tested it. Said, oh, we built this in the city. We've never been outside of a Wi-Fi connection. I don't know. I mean, it seems like they would actually be putting that in there intentionally. Pi Zero seems a good choice of hardware. Is that fast enough? Mine's run for years on an original Pi Zero, and it's still fine. Okay, oh, there's the line right above. You have it on an OpenWRT. I wonder if my more modern router can actually run it. I know the Verizon router can't, the one that came from Verizon that we have to use. Oh, you've got it even just powered off a USB. That's interesting. Yeah, I should probably set that up for this network, because that way I wouldn't have to worry so much about installing Firefox and uBlock Origin on my folks' computer. They could just use it here without tons of ads. One thing I despise is smart TVs. For all the pomp and circumstance, all the nice things that smart TVs bring into the fray, being able to have multiple services on a TV, you know, like having Netflix go directly into it, that's great. But I've never seen a smart TV that wasn't just screamingly slow. Any of these smart TVs, you open stuff up on it, and the processor's like trying to pull up graphics and stuff. They're like, there's your image. Like every time you try to do something on a smart TV, I cannot fathom why they can't make a snappy interface. Why they have to lowball the processor on the thing. It's like they design it to run on a computer, and then they put it into some like embedded cell phone computer style thing. Miss the days when washing machines just had a motorized wheel with bumps on it that coded which pumps to turn on or off. I had to analyze many devices like that in a previous life. They're not that great, but it literally was just a little gear mechanism that spun, and it would just hit two pieces of metal like that, and that would turn on and off the motor. They're kind of trash and they stopped updating the apps in a couple of years. I didn't know about that. Cam wheel automation. It's like a brain slug on top of my router. That's a good way to look at it. That's pretty funny. But the Pi Zero doesn't have like an Ethernet connection. It's just doing that all wirelessly, huh? Mom's old TV couldn't get updates for some streaming services and they stopped working. Jeez, I don't look forward to that. Could you imagine, like, and they've done it in the past, they can just brick your TV if it's too old. USB to LAN thing on it. Oh, so it's like one of those cheap things. That's great. Yeah, they can break your old TV, and so they can do that to your car now. What's going to happen in, wow, the joke of chat expanding with the zoom in is a little intrusive when my chat's actually healthy and active. Thou shalt purchase a new TV. That's what I'm wondering about, because what happens to the cars? What happens to my Roadster when Tesla decides that thing is 30 years old? You're done with that, right? Do they go boop and it deactivates all the Roadsters? I mean, there would have to, but are there any laws that force them to put software on it that allows it to run indefinitely? Maybe it has that, but maybe it doesn't. So a couple days ago, the landlord has a new smart TV and it allows for the reading of HVEC 265 movie files and can read and play 50 gigabyte movie files, but it has a heart attack trying to, it has a heart attack trying to load emphasizing the wrong words. It has a heart attack trying to load the interface. Yeah, there's a USB slot on the TV upstairs and I think it does something similar. I don't know. I don't ever want to mess with it for that though. Tesla's been doing that to cars for a long time. All the modules are serialized. If you pull a seat controller off a totaled car because yours burns out, say goodbye to your car. BMW does that as well, but there's I have the tools on a laptop where I can plug into the CAN bus and I can tell it, hey, this module, erase yourself, here's some new software. And the module goes, yeah, all right. And then it pairs itself to the car. So that's how I got the ABS module back into my car. I had to follow some tutorials. It was relatively simple, but having the German program, Tesla uses the LIN bus, then it has to be beastly slow if you've got to update an entire module. But yeah, so through the CAN bus, through a laptop, yelling at me in German, Nein, ich feigen file, and it's like, whoa, okay. But if you, it basically has all the modules in my car through the whole model year of the run of my car. So I'm able to load it up and send it and reflash a device and get that registered so that my vehicle goes, yeah, okay, cool, we can start up now. Because there's all kinds of two-way communication going on through all the modules. So Tesla doing that with certain things is not new. There's probably a way that you can beep, boop, bop, get something to, like a used part to work. They don't want you to be able to do that, and that's what all these right to repair arguments are. There's and boy howdy, maybe you don't have to make it available for sale, but it would be nice if car companies made the programs that they use to do this kind of stuff available. Because again, that leads down the slippery slope of, well, business is going to business, and if business is going to be driven by bricking everybody's car when it's 10 years old, they're going to do that just because they're just like that. They don't go, you know, we should probably take the high road here. They don't do that. They have a fiduciary responsibility. They say, this will make us more money. Push the button without breaking the button. They'll push the button. Like, their money boner will push the button. I hate it. I hate it so much. And I'm so glad for the people that are fighting right to repair. We had somebody in our Discord fighting for the right to repair electric wheelchairs, and they kept us updated with stuff too. And I'm super duper thankful, and I love those people. Legally obligated to disregard the high road. Yep. Yes, they are. And by the way, I listen as influencer. I would rather talk about fun conspiracy theories, but this is not a conspiracy theory. This is indeed how this stuff works. So, you know, a lot of people on pulpits like mine will sit there and tout conspiracies that are easily disproven. This one, go look. This is just what they do. This is just how business works. It sucks. Is this Rhine? I don't even know what that is. What is that? I just have to say, like, it feels like I'm being conspiratorial here, but the guy's doing right to repair. Oh, yes. That's who it is. Yes. That jogged. Sorry, those certain things. It's like, why didn't you say his screen name? It's like, because I couldn't remember when I was talking. I was thinking about it as the words were leaving my mouth and trying to structure my sentences properly. There's two little overworked dudes at the beginning of a conveyor belt pulling all these words that I know onto the conveyor belt and trying to arrange them properly before they end up going into the hopper where I say the words. There's very little editing that can occur in my brain at any given point in time. Those two little dudes are very overworked, especially when streaming. I'm so glad we have cheap ESP32s now. It makes hacking bricked e-waste appliances so much easier. Yeah, that's the ESP32s and your 8266s. The 32 is luckily extremely powerful, and most appliances can run off of just the dumbest microcontroller you could find. Especially something, you know, washing machine. What is it? Do this cycle for about this amount of time, then do this for this amount of time, maybe pulse this, turn this on and off. And maybe if we feel like it, we put a screen on it, a couple LEDs. That's exactly what, you know, microcontrollers were invented for. So it's pretty cool that you can take over some cool e-waste. The e-waste that I really would like to find, and we kind of failed, and we looked at it before, was the ink tank printer. Because if you could take one of those, not fully apart, preserve the printing mechanism and have it print onto a linear axis, you can put things like plastic objects, front panels for stuff, on that printer, and you can use ultraviolet dye, or whatever it is, ultraviolet ink, so that when the printer prints, it's actually printing a plastic, and you can have like a plastic color label on a panel. That would be really cool for me. Unfortunately, that printer that we had was not cooperating. It did not want to cooperate. Something was deeply wrong with that printer, and maybe we'll go back to it at some point. That's just another project on the pile, though. Because it would have been nice to be able to print module markings. We're going to take a look at some modules today, though. We need to tune up some of these things. So I'll get started in just a bit here. I'll get started in just a minute. Just a minute. Try to keep up with alerts here. Minimize that. Take a look at this other thing. Is ESP32 still the fastest, most capable? I see there's other variants such as the S2 or C3. I mean, the state of the art right now is moving so fast that it's impossible to keep up. Somewhere, someone probably made something that's super powerful. No word as to whether or not it's going to be the one that stakes claim as the one that everybody uses that's more powerful now. I don't know the state of that. I'm sure there's many very capable modules or whatever, but the ESP32 seems to have staked its claim as like the de facto go ahead in terms of Wi-Fi modules, especially because of its price. There will always be stuff that beats the common platform in every way. Using the common platform has the advantage that you can get support. You can get help. There's so many choices, all the different modules with different I/O capabilities. Yeah. And the only reason I would say to branch out is either saving money or getting some of those little features that you can't get from the original thing, that's not, man, it's so complicated these days, right? Mostly for my purposes, I'm going to be using what I have on hand. We're going to be in that mode for a little while now because of just everything. You know why. Stupidity, mainly. And the war against it. So we're gonna probably phase into just using things that I have on hand. Because as soon as those stores of things dwindles, it's gonna be kind of shitty out here. It's gonna be like an ESP8266 will be like $4, which sucks. Highly optimized stupidity makes the world go round. COBOL? What is that system that all the banks use that's so old? I don't trust the squiggly waves. I hardware everything. I mean, that would have been a good goal for me to do this modular synthesizer, is to say everything needs to be analog and try to work within the binds of analog with 2 HP modules, but I decided to just buy the circuit board, so that had a smattering of both digital and analog in it. I've learned a lot. I've learned quite a bit, actually. It turns out I really wasn't up to date on my analog design stuff. I didn't do much with analog design in my career. That was mostly logic and digital. And then I did a little RF, but that's sort of a different flavor of analog. There's many different weirdnesses around that. So actually getting into wibbling waves and voltages has been a good little departure. Yeah, you know what? Screw Eurorack. I'm just gonna twist wires together. We're going with ladder logic. We gotta get this thing up and running. We're gonna work on that soon. I think next week is gonna be Burn the Subs week, and we're just gonna work on this. So I'll be able to get you guys on the laptop that I have over there. I have a problem with that laptop. It was a family friend that gave it to us, and it's fairly old and fairly incapable. I want to put Linux on it, and maybe I can do dual boot with it. I probably should do dual boot because the BMW tools exist on Windows, and I don't know how well any Linux system emulating Windows is going to be able to use the COM ports, unless they really have worked stuff out really well. I would love to use the little handheld that I bought as my car programming tool as well, and that exclusively has Linux on it. It has Bazzite. And so if I could get Bazzite to properly emulate the BMW car tools and do the whole CAN bus programming, then I have this nice little thing, and that laptop is fully combustible or compostable. I can throw it out or reflash it and have it. Right now, it's going to be it's got Windows 10 on it, so it actually runs much akin to a smart TV. It barely runs with Windows 10. But I can have that machine over there for when Julian and Dave are here playing music stuff. They can actually see you guys. That'll help the interactions a little bit. Anyway, what are we doing today? I didn't even put up a start soon because I'm so sick and tired. Anyway, I didn't put up a smart soon. I always on the horizon, the smartness. I continually evade being smart. Anyway. Starting now. Stream. What are we doing? Tuning. We're tuning modules with my module tuning module that I tuned. I tuned the module tuning module, and we're going to tune modules using this module as a tuning module to tune the modules. That's it. That was the whole thing. I would like to start, though. Well, we'll start, and I'll familiarize with what I'm actually doing with this thing. I can go over the code really quickly, and then I can show you the thing and how it works, and then I can throw a signal out of this thing, and I'll show you the different modes. But basically what happens with this thing on the Arduino is it starts up, gets itself ready, and then it basically just pushes waveforms out. And as it's doing that, it looks to see whether or not any of the buttons have been hit. I'm using the Bounce 2 library, which is really nice and easy to use. Essentially, when a button gets pressed, you update the bouncers, then I update the outputs. This is all there is in loop anymore. There's 2 functions in my loop. Update bouncers, update output. So when we update the bouncers, we literally just bouncer.update. And then if something happened, if the button fell, so when it rises, that's fine. We let go and something happens. Actually, that's not how it is. It's the opposite. If you push it and then something happens because that's it falling. The falling edge is when the button gets pressed because it has an internal transistor, the button, and it's configured as an input pull-up. So when a thing happens, I then update the thing that needs to happen. And what happens is one of 3 modes advances. The modes only have length. I got rid of the array that they initiate because I don't know. It could be simpler if I did an array of functions that would have to be pointed to if the certain mode. That kind of programming confuses me. So instead, I'm just doing if-elses, and I have a length for the number of modes that are available per button. So each button is just initiating modes. The top button currently does nothing, but what I want to do is wrap that into its own thing so that I can have an entirely different testing array. If I need to actually, I got to think about how I would use 6 channels in a different mode, because then this could change the big mode, and then these 3 could change the individual bank modes. That's how I have it right now. And I could probably totally reorganize it and make it completely change every time. But right now, this is just like, hey, can I do this? Can I make this actually useful and functional? Let me hard code a lot of these things that can later be expanded on. So I've just got 3 sizes, and when that variable gets to the size, it'll reset itself back to the original. Whew. Whoa, what is that? Red light. Red light, we got a sub. Wow, that's hard to see, isn't it? We're gonna put subbed, where is that? Streamlabs, this thing? Which one are you? No, you're not, no, you go back there. Where the heck is Streamlabs? No, you're the same thing. Stop selecting that. Is it so hard? Oh, I see. I need to go to, hold on, I'm gonna just fix this real quick. Frameless overlay. No, that's not it. Audio source, scope, chat, face, micro. Oh, no, that doesn't have its own thing because it's situational. Right, okay, so in this one, there's Streamlabs, but I don't have any handles on it. Huh, it's, the source in OBS has gotten so large that I can't, here, let's reset the transforms. Oh, I can't. Oh, it's locked, that's why. Unlock that. There she is. Yeah, let's put Streamlabs like right in this space. That'll be a little bit better. Okay, there we go. Let's lock that again so that my dumbass can't mess it up. Paul Barrier, thank you for the 3 months. For the module tuning. Thank you very much. I really appreciate that sub. That's a nice little 3-month sub. That's nice. That's nice. So yeah, anyway, we monitor the buttons to see if somebody pressed the button. If somebody pressed the button, then we plus the mode. We just add a number to the mode, and we set our button change flag to 1. The button change flag just allows us to go through all of the different functions in the software and not execute the entire thing every time. I just have a little catch at the beginning of all of these things that say if the button was pressed at the very beginning. If button change, do this other function. And so the other function is really where everything exists. That's this one here. Screen wave set. I decided instead of having 2 functions, one for the screen, one for the waveform, I would just have 1 function. That way we read the mode and I just do the business of the mode, which is updating the screen and then putting the waveforms on the outputs. Just do it all in one pass. So what happens is if the case is 0 for this specific bank, and up here, by the way, this is where we make the, what is it? We clear the buffer, everything's wiped. Then we make the bar, the top bar circle, then the upper bar circle, then the lower bar circle. So that's the 3 circles in a vertical orientation. And then we enter the switch case and we look at the mode for those circles. So the bar gets called square gate. The circle gets high, low, and 0.4 hertz. Then we put that high-low waveform onto the channel. And then in the background, the library is doing all the business of actually setting the voltages. before I had to actually operate this thing in the opposite direction. I had to realize that there was an inverting op amp sitting on that output. So if I were to do things like send a pulse, I would have to make sure to cater that pulse to the fact that things are going to get flipped. However, learning to actually use the audio tools, I put an amplifier block in front of each of these outputs. So now when this goes out into the physical world, it is in the right orientation. It is, well, no, when it goes out into the physical world, it's upside down. It is the opposite of what it was. That then gets inverted by my inverting op amp when it gets amplified up to 10 volts. So we're able to make all of the, lurks to take a phone call. I'll catch up with the chat. I'm trying to explain something. So yeah, anyway, I do all the business of that in the switch case. That gives it a nice organized block. I like switch cases. They help me organize my code and not have it balloon completely out of control and become a bunch of nested if-thens. So I do the business of making all of the channels here depending on what case is activated. And so each channel gets its own little block. That's the left-hand side channels, then we've got the middle channels, and then we've got the right-hand channels. In the future, I'm going to make that fourth button probably, well, at screen wave set as the mode in the list. I could probably do like a list and then do the whole pointer, the complicated pointer thing that I'm talking about. And I could probably put each mode on a different tab of the UI here. And that would help sort of compartmentalize everything. But yeah, all that stuff coming together, boom. Now we've got a nice little tester and I don't have to drop into the software every time I want to know what it's doing. Screens just helps me know what's going on. So if I want to change to the third bank, from the low, this is a LFO / trigger. So we've got triangle on top, pulse on the bottom, boom. Now I've got saw on top, pulse on the bottom, but a different frequency, a different frequency of pulses. There we go. I created synchronized clocks at my school. I'm a teacher. The ESP32 sits behind the clock, with a hole drilled at the 6 o'clock position where I have a CN, well, I remember this actually, a CNY70 distance sensor. The sensor detects the eclipsing hands that pass in front of it. That's funny. That is a crazy way to do it. Can't you get like a real-time, like atomic clock to phone in or something? Couldn't you put the ESP on the Wi-Fi and just have it sync up with the national thing? That is a crazy way to do it, but it's very clever. Hold on, I got a cough. I don't know why I'm getting dry throat today. Well, actually, I can tell you exactly why I'm getting. It's because my glucose level is 233, 223. It's not crazy. It's not as crazy as some days, but 223 is out of range. My pump will bring it back into range, and then my throat will stop being dry for no reason. Just reread your comment and decided to just stick with the ESP32 for any project. It's cheap enough and very capable. I have a list of nuances of each pin. Some are I/O, others are just I. Spice, I don't know who Andreas is, did a great video about the ESP32 pins and which ones are actually usable. You need to get that in video form. You can't just look up the pinout. With the microcontroller like these, the TC4, I'm just looking at the pinout online. The clocks were too expensive. Mine's about $30. Clock included. I see. Well, no, I mean the whole clock, yeah, but can't, here, like if you got like an ESP8266, internet time or something like that, getting date time from NTP server with ESP and Node MCU. You just do that. Although I guess the ESP doesn't necessarily know where the clock is set. That's why your little clock eye is there. Why is this in the middle of the, what the fuck is going on here? Complete your collection of spreadsheets and WWE merchandise. What is going on? Why is that 500 times on this? What the fuck? What are the ads on this thing? Jeez. Ridiculous. Let's see. So, okay, there are NTP libraries for syncing up to internet time. Interesting. This whole board is yeah, it's a teensy driving 3 amplifier with, what is it called? I2S. The Teensy 4 has 4 channels of I2S, but I'm only using 3 because the mutable instruments design of a similar testing module only had 6 channels. So I'm like, well, okay, let's just do 6 channels and see if it can handle it. This can do 8, but the pads for the I2S output for channel B, it's A, B, C, and D. Channel B, the pads are on the other side of the board. So they're just solder pads. So no plugging it in to multiple different devices. The screen is I2C. So it is running both I2C and I2S simultaneously. This is a Teensy 4. It can run up to 600 megahertz. This thing is a beast. This thing will do your homework. Like, it won't be running out of processing ability anytime soon, which is great for a testing platform, although it's a $20 microcontroller. So not entirely, I wouldn't necessarily be using it in a final design. I think a much lesser capable processor would still be able to do the job of sending these waveforms. But again, I'm not selling 500 of these things. So this is just a test platform for me to be able to tune instruments. And if I were to buy this, it would be somewhere around $300. I could probably save money and get the kit form, but it would be using a much more terrible microcontroller and it would be a very old design. So I decided to make my own. It is inspired entirely off of the Amelia Gillette designed module testing module. Mine ended up being big enough, small enough rather, to fit in a module, and the hardware that this is eventually going to get will be on a printed circuit board, and it'll have a vacuum fluorescent display just for the cool factor of using one that I had sitting around. So for now, this thing is a mutant, but it'll allow me to move forward with the modular synthesizer stuff. So I want to actually get to like tuning something. Let's get like an analog module. Probably, well, we can get something that I've already tuned and just mess with it and see if this thing is good enough to help me tune other modules. I got too much going on is what's going on. Here, I'm going to move over a little bit here. Oh, there's stuff in the way. I'm going to cause a huge avalanche of stuff if I position myself improperly. I've got this thing sitting here. These are all the USB upgrades, and then my Eurorack rack that doesn't have anything in it. These are all that high-speed USB stuff that'll hopefully allow me to use the Stream Deck XL in the near future. I would have worked on that today, but I got to stream. Setting up Linux on an old PC is such a true story. It's, you know, hey, you got to keep that hardware running, and if you only need to browse the web, some fairly old hardware can run Linux pretty nicely. But yeah, that's the constant stream of like stuff that people give you as somebody who's recognized within their social circle as the tech guy. You end up getting a lot of, for instance, power supplies that you just don't need. Here, these are fun. This is my high-low, low-high. I don't know where that's going to be useful. And I don't know why they're sort of out of sync with one another a little bit. That may be on me. I may need to do a little tuning. We may need to build into the code some tuning calculations. I don't know how many digits the actual, how many digits I can feed into the functions. But if I hit this button, it changes into a sine wave. Woo! There's a certain beauty in the simplicity of it all. Doink. That's the wrong one. Doink. Good stuff. Good stuff. Anyway, yeah, let's see if we can test an actual module. So I'm gonna put my scope probes all the way over here. Wait, which one did I just move? Okay, yeah, this is the blue channel. So now what I can do is I can just use these to indicate which channel on the scope I want this to go to. Oh, and there goes one of my screws. Gotta watch out what's brushing this area over here. So yeah, these are now my test cables. I probably should have put 2 plugs on the back of this thing so I wouldn't even have these wires here. That would have been clever. Maybe one day I'll build that. I can always 3D print just a little plug holder. Why is everything stupid? Hold on. I didn't keep which one was which. Okay. You listen, Long Dog, this is like college. You don't need to announce that you're going to the bathroom. I don't need that noise. It's okay. You guys are allowed to leave without saying goodbye. You can watch other streams. You can even open up the browser on your computer and go to a pornographic website because they have those on the internet. We're just on the internet. It's okay. Just go do your thing. Jeez. Not your mom. All right, so. It's getting a free bottle of hot sauce. I see. You just want to talk about hot sauces. No, I've had it with hot sauce for a little while. I got Thai food last night. I had too much spiciness. What's up, Last Miles? There would be burn the subs. Listen, we're working on it next week. We're going to work on it next week. I said I would work on it this month. We're going to work on it next week. Last Miles subscribe with a tier 3. No way. Last Miles. Oh my God. Oh, by the way, everybody here should check out Last Miles. I'm going to do the little shout out thing. Right? Hold on. I'm just going to verify a couple things here. Have you been streaming lately? Just checking up. Yeah, we're going to shout out. This isn't a paid shout out. This is me deciding to do it. Although it could look very much like it was a paid shout out. Your check is in the mail. Thank you so much for the tier 3, Last Smiles. I really appreciate that a lot. Oh, it's not smoking? I assumed it would be smoking. Smonin'. I don't say VODs. Lately, I've been fighting with Risk CV hardware. I don't know how do you say that? Risk V, right? Risk. New people are always favored. Hey, if you want to see some cool stuff, check them out. Risk 5. It's not Risk V. Oh, that sort of pops a bubble for me. Huh. I thought it was Risk V. All right, let's get into this a little bit. I don't have speakers over here. We'll grab them when they're relevant. I've got all these modules, and the reason I've got all these modules is because you can just buy the circuit boards for these modules. You can just buy the circuit boards and then do whatever you want with the rest of this. This is a BMC 15. I don't really know what that's supposed to do. So when I built all these modules, because they were just circuit boards, these are musical instruments, right? They're designed to get a voltage in, and they sometimes produce weird wibbly voltages out. Generally, the audio in Eurorack synthesizers, plus minus 10 volts. So we have our oscilloscope over here at plus minus 10 volts. The reason it's plus minus is because when you're dealing with electronics like this, that's the way all the analog stuff used to be, and so it's just easy to use. So you have plus minus 12 volts coming into these modules. They operate in plus minus 10 volts. If you plug that signal anywhere in the synthesizer, it cannot harm anything. Everything in the synthesizer has to be able to operate in plus minus 10 volt scale of voltages. Now, in some of the cursed modules and some weird stuff, you can get higher voltages, you can get up to 12, but it's generally 10 is the maximum voltage you'll see. There are different types of signals though. You can have a trigger, which is just a little pulse. You can have just a little pulse. You can have this one here, and that is just a trigger. And typically that's used in percussion. It's used for a lot of other different things too, but it's a millisecond or so pulse, well, a couple millisecond pulse that can set stuff off. And it is up to about 8 volts. They typically cite 8 volts for that. So I tuned my tuning module, tuned to the tune of 8 volts for that one. Oh my God, purple. Last Miles is gifted subs. You don't have to do anything beyond a tier 3. Tier 3 subs are like gifting 2 subs every time you sub. That's more sub for your sub. That's enough sub to send to the bottom of the ocean before it implodes. Last Miles, thank you so much. And if any of you are here and not lurking who received subs, you thank that man, that person. Thank you so much. Yeah, what's going on? Sorry, what's going on over in chat? I was on a rant. I could use a sub or a sandwich. Hey, just hoagie sounds good right now. I have 2 machines running Risk 5. Jeez, I'm not going to get used to saying it that way. And one is FreeBSD. That's mine over there. I have FreeBSD on my server. Actually, is it still called that? I think it's called something else, right? And the other's fighting me tooth and nail to get Gen 2 started. They're horrific. Both are horrific. On top of the Cadillac S5 Risk 5 P550 board. What is this picture? Okay. Oh my God. No, the cursed project that I would have is this guy up here. This is out of some kind of a telecom rack, this thing, and it's a Windows machine. It is a Windows XP machine with no, it does actually have, it has a whatever it is, VGA port output. So there is actually like a desktop for it. But yeah, this is a picture that Last Mile sent with the thing that he's working with. So this is what he wants to literally crack over his knee and destroy forever. WinXP32 is still alive. I don't know. I would love to just put some kind. What I want to do is make this the computer that would run something like a router, like an XY table, because it's a fanless system. It's also completely useless. It's less powerful than a Raspberry Pi. It's like, why does this even exist? It's so heavy. But being fanless makes it so that I can put it in a heavy dust environment. I was ranting about RISC-V. Yeah, so the module tuning module, we have a pulse that I can use, but plus minus 8 volts and plus minus 10 volts are not all there is to it. There's also low frequency oscillation control signals. So what this is essentially doing is linearly moving a knob to one end, moving the knob to the other end. That's essentially what this is emulating. That's plus and minus 5 volts. Now, all of the Emily Gillette made hardware does plus minus 5 volts for control signals, so I'm emulating that. I figure they know a lot more than I do. They know so much about modular synthesizers that they literally went, fuck all y'all, I'm out. I'm out. My designs are now free. You guys can do whatever you want with them. I'm out. I'm sick of you people. And so they left the whole scene and they left behind this legacy of work that you can see evolving as they go. And so I'm taking the latest and greatest that does the thing that I want to do, stealing that circuit, because I figure it's got good lineage to it and it probably works really well because people are like, oh, mutable instruments, they're a legend. So, and I understand all the designs and they are all in AutoCAD. They're all in Fusion 360, or at least formats that I support with Fusion 360. So I can take an Emily Gillette schematic, pull that part in, use the part, and have the same footprint on the PCB that they used. I've done some improvements to that, but they're, you know, pretty cool. Pretty cool to be able to work at that level with something, because there's so many CAD softwares out there. There's so many different things that people use in order to invent circuits, and there's so many different design philosophies and designs out there that it's nice to have somebody who did something similar to what I'm doing meet up with me on software. It's a cross compatibility that I did not expect. I have my battles on the RPi 5. But not nearly as much mental trauma as RISC-V. I'll be quiet. My battle with the Raspberry Pi involves this thing, and it's all in Python, which is actually kind of amazing, to be honest. Yeah, I'm not building on an actual breadboard. Can my synths be synths to synths? I think your synthesized synthesizer could probably synthesize some kind of synthesis, some kind of synth to size. Smell toast. Yeah, so with Burn the Subs, we're using a Pi 3B Plus. Not the Pi, I have a 5. I don't know if I'm going to use it with Burn the Subs, because Burn the Subs doesn't do a lot. Basically, what's going to happen is over MQTT, we're going to get a name, and then we need to do the same algorithm that we've been doing for years, which is just randomly place the name on the board and see whether or not it's actually intersecting with any of the names that already exist. So it's a Pewee database. We used Pewee because it's funny. That's the only reason we used Pewee for the database. And it was easier for dumb bother to have chat yell at me about and get me to actually use functionally. So we're using Pewee for the database. It pulls up the database in memory, rebuilds the whole board, and then starts trying random spots. And I think actually, no, we changed that. I think it pulls up the local area that it's gonna, no, it pulls the whole board up. It pulls the whole board up because it makes it faster for it to do multiple rounds and checking spots for names. When things start to fill up, loading the whole database is a trivial amount of time compared to placing the name and pulling it up and doing the calculation locally. I forget what we did. I don't know, but that's my wrestle with Python. We'll get back to it eventually because we need to tune it up to use an API. Anyway, so in the grand scheme of things, I've built a module tester module. We should put it to the test and see if this thing works properly. I think I have all of the appropriate signals on this thing. I've got my LFO. I have my actual tuned notes. So that's the center bank here. Let's get a little closer and so you guys can see the screen. I worked hard on this thing. I put a lot of work into this thing. I made little bubbles that the different functions were in. I probably could have not done the bubbles and then I wouldn't be kind of squished for space. But anyway, this is a C4 note. This is an A0 note. And you can see them changing there. I was able to actually look on the oscilloscope itself and get it to measure because I spent $1,000 on a $600 oscilloscope. I really should have waited a month. That was my big birthday celebration. I really need to get over the amount of money that I spent on this thing because it is paying in dividends being able to put the scope in real time up on the screen like that. Pretty cool. I don't know if I'd recommend getting the DHO 914 out of the box. The entry level Rigol is the one that I think I would recommend because if it does all the same stuff that this one does, it's just awesome. All the connectivity is really important to me. And if I were remote, I could actually change settings on the thing by clicking on the screen because it's a touch screen. Anyway, so yeah, we have a sine wave at 2 different frequencies. And what that allows me to do is to test. I mean, the sine wave from a VCO won't really be synced up to this, but I can at least put the 2 notes down, and flipping between the 2 voltages for 1 note per volt allows you to then tune the slope and the offset of whatever the note spread is. That allows you to match the 1 note per volt standard. It helps you actually tune the thing in a sense that it creates the right notes. So this is a low-high control signal, so it's basically the same as the LFO. Oh, I unplugged the wrong one. Hold on a sec. Except that this one goes low to high and the other one goes high to low. How does he come up with it? It's so complicated. And then if I hit the button, boop, it just does a sine wave. Residual waves that look, from all the sci-fi things. There's the oscilloscope music channel too on YouTube that guy produces actual music that if you plugged it into an XY oscilloscope, which is a different mode for this thing, it would actually look like shapes and stuff. Pretty crazy. You basically, on the oscilloscope, for anyone that doesn't know, on the oscilloscope, what we're doing is we have voltage over time. So as time rolls on, the voltage is then logged by the oscilloscope and we can see patterns. If we take it instead so that one voltage is X and the other voltage is Y, you can see emergent patterns and stuff like that. It's something that's fairly rarely used in oscilloscopes, but it is a useful function in that you can plug it into your music and see how cool it looks. Everyone does that at least once or twice. Yeah, everyone's nerds and we all love a good visualization. Okay, so anyway, the combination of all these signals coming out of this bastard at the same time should make it so that I can actually operate some of this equipment and do functional tests on it. So let's put that test to the test. Let's get our testes in a knot and start testing stuff. Let me just get my bolts out of here. Liciduous figures. I gotta look up these words you guys are using. It'd be very easy for somebody to find a heavy vocab word that means something awful. Where did that bolt go? Oh god, it's on the power supply circuit board. What a terrible place for a conductive bolt. There we go. Am I putting this back down? Yeah, like this. Like this, with everything out of the way. I have to have this plugged into my computer ground, otherwise these two, the channels for this controller up here, get all squirrely. I do not know why it's like that. We tried to look at the answer to that. If I have my computer plugged in down here, the addition of this ground stabilizes whatever the digital output is that goes up here to this module. I can also hover my hand over this area of the PCB and it will stabilize those channels. I don't know why. And we tried to get to the bottom of it. We were not able to figure it out. Are you tuning modules with tune modules to check the module tuning, or do I just have a seizure? No, there's something wrong with your brain. But also, I'm using a tuning module to tune modules. And this is the module that I tuned to tune other modules. It actually does make sense. I'm not just throwing that out there. I am, but it also just makes sense. That's what we're doing this Friday. Yeah. Am I having a seizure? A little bit of column A, a little bit of column B. Far be it from me to rid you of a good time. I have to get back to the design of the mixer and the keyboard project. Those are two AutoCAD things that I just, when I think about them, I just get depressed, and I stopped working on stuff for a little while. So I've had a couple weeks where I've been completely useless, and that's coming to a close. I think I finally have the mental fortitude to go back to those projects and actually follow through with them. Part of it is I want to get Julian off of my back about the mixer. He deserves a little bit more of my time before I can tell him no. Have you tried using Daisy Seed? Having some thoughts about how to use Raspberry Pis, Daisy Seed, or even Arduino mostly as a sound source. I have not heard of Daisy Seed. The Seed Studio things that I use, where'd that go? It was up here. Well, I guess this is an example. This is a Hajiwo design. Hajiwo is a YouTuber that does a lot of modular synthesizer stuff. He does it cheap in that he's not spending a lot of money, but I think Hajiwo kind of skips on like listing his op amps and stuff like that. He'll say like, oh, it only uses this, that, and the other thing, but it's like, well, what about the substrate that you put it on and all that stuff? So Seed, the closest thing I got is the Seed. What is this thing called? This is the. What the hell was this thing called? Oh, the Zhao RP2040. So this is essentially just a tiny little RP2040. But Seed Studios Zhao. I don't know. I kind of like this. It's cheap. I bought it just for this project because the Hajiwo used one. It's tiny. It fits in the modular thing if you're doing things a particular way. I really respect your workbench. Mine looks like a trash explosion that includes working hardware stuff. I mean, like, I'm no exception. Even just this tiny little slice of my desk where I keep this stuff. I do try to clean up very often, but that usually ends up in like roving spots of cleanliness. I keep circling back to cleaning up and cleaning up and cleaning up and cleaning up, and every open surface is it's like a physics, it's like a law of physics that every open surface accumulates stuff in a shop like this, especially an electronics shop. You're like, where am I going to put this? Oh, there's an open space. And you just put something down there, and you don't know that you're actually doing yourself a disservice by doing that. So I've invented a lot of different organization tools to help with keeping this place from being a constant explosion. It turns it into a constant rolling explosion. And what I think I need to do is go through my project boxes, reorganize them a little bit so that I've got room to think. Because I would like this place to be a bit cleaner. It's better for presentation to people coming in to see what you're doing. If it's clean, if it's a huge mess, they can be impressed by the huge mess, but it's, I don't know, it's a trade-off. It's an Arduino, but you program it with pure data, C++, or even Max MSP, believe, and it's specifically made for audio, and there's even a version for Eurorack voltages. Oh, that's cool. That sounds cool. Does that mean it's expensive? If I did like a time lapse of the shop, it would probably just look like a bunch of trash blowing in the wind. I know it means that it's, yes, I'm utilizing my bench if it's filthy. But I'm really getting sick of being on top of myself in here. I don't know to what end can we tune sheeps. I think maybe we just test the theory of operation of sheeps. We got to look up what sheeps is and if I've loaded any cursed software. There is a knob right here though, so that might actually be something that we can tune. Not sure how to describe that, but it's the way things should be. Yeah. I mean, you know, I have methods of organizing. My methods of organizing are so old that they filled with stuff. So I need to reorganize the organization. Those are some knobs. These are on Alibaba. They were the cheapest knobs I could find. They're metal, they're anodized aluminum, and they're black and knurly, and they look awesome with the rest of the stuff that's going on here with my engineering gray PETG front panels. It's like 30 euro. Oh my God, that's actually pretty expensive. But with the shipping, it's 100 for Greece. Yeah, well, for America land, where I am, out here in the home of the brave, things suck. So I think it would probably be a lot more expensive if I were to import that. Metal anodized knobs. These were like super cheap though. And oh, and the other part of it is that they're small enough so that they can fit in sort of the more compact setup. What is Sheeps? Sheeps is a mutable it's a mutable instruments module that I know nothing about. So let's look up. Yeah, so it is a separate firmware loaded up into Tides. I don't know if Julian might have been telling me that I should go back to having it just be Tides. I think this is a control module though. Yeah. A cluttered desk is a cluttered mind. What's an empty desk? You're suspicious of a bench that's organized. I mean, mine's organized. I was going to move the mixer in over there, but Tide Pod modules. Metal anodized knobs. Blah, 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 blah. Classic. Sorry, I'm keeping up. I'm keeping up. I'm keeping up. Shape glass light bulb covers we had in the 50s. Not really. Has somebody made a Tide Pod module? Pods. Oh, these are the things that Julian has. These are his little Eurorack. Oh my God, how expensive are those things? Jeez. How much did he pay for his little, that's $100? It's got a power supply in it at least. Tide Podule. I'm putting Tide in my pod. All right. Anyway, Julian has one of those. Oh, this person is debating whether or not they want to spend hundreds of dollars on Tides. This module is called Tides. Let's learn about what the hell Tides does. So mutable. Listen, we did all the building and programming of this stuff. I didn't have time to sit down and go, hey, what does this do? Because all I did was I went to Julian and I said, Julian, hey, what do I need to run like a normal synthesizer? He said, you need one of these, and these. And I said, cool. And so I went and I got the circuit boards for the thing he said, the thing he said, the thing he said, and the thing he said. And then I said, that one looks cool. Oh, look over here. This one looks neat. Oh, this one does something cursed. Like I just went crazy. I spent like $100 and something on just circuit boards alone. Tides and the other mutable instruments modules used some nice parts, and they also used some obsolete parts, so they were rather expensive to put together in the end. This does not look like the Tides that I have. This is the Tides that I have. That's Tides from 2018. Ah, I need old Tides. I need Tides from 1994. Or at least, you know, theoretically before 2018. Tides original. It's like a Werther's original. Oh wait, this is Tides. No, I just clicked on Tides original. Oh no, it collapsed Tides original. I hate this interface. There we go. Tides original. This has, yeah, that's the one. 3 operating modes: single shot, attack, decay, sustained attack, sustained release, looping VC, LFO, VCDO. 3 frequency ranges. Wait, VCD, I don't know what that is. 3 frequency ranges: low, medium, and high. Freeze gate to stop the oscillator and hold its output. That doesn't totally help me. Okay, so this thing isn't, I mean, yes, we will tune this, but this is more of like a CV controller. Mess desk. Oh no, not this again. What is this? This is Last Miles, this giant. I mean, that's not so bad. You could clean that up. You don't have to even. That looks fine. Although the flying hardware is the flying hardware up there that's being held up by what looks like it's power cables. That one is being tied with Ethernet. That's impressive. It is a proper desk setup indeed. Wait. Huh. Chat wasn't updating, sorry. The dome-shaped glass light bulb covers we had in the 50s. Oh, no, it is. Hold on, sorry, I'm checking. Power over Ethernet. If you don't have a PSU suspended by Ethernet cables, are you even engineering? That's, you know, that's a debate. One small part of the bench. Oh, I can imagine it's an epic mess. If you guys check out Flatulent Gonad too, if you guys are interested in a desk that is what I would consider like a bomb site of just stuff. Okay, so we're trying to learn about what the hell Tides does. I have exacerbated the problem by putting new firmware on it. I put Sheeps on it, which gets a kitschy picture of just some guy doing stuff. Sheep is an unofficial firmware for Mutable Instruments Tides, which implements wavetable synthesis. This update completely replaces the stock firmware. Oh, okay. Turns Tides into a new module. All right, I guess it's not Tides anymore. It's not possible to run this firmware side to side with the original version, so it's an either-or affair. I think Julian told me to turn it back into Tides, but I'll keep it as Sheeps for now. Sheeps provides 3 banks of waveforms laid out in a 2-dimensional grid with continuous interpolation between waves. Think of it as the director's cut or dub version of braids. Okay, I don't know what braids is. The filter wave folder is controlled. Wait, what? The filter wave folder control is still available for further filtering or distorting the sound of the raw waveform. That sentence is very clumsy. And obviously you won't need a voltage controlled amplifier because of the level CV input. Okay, so what the hell is happening here? The mode switch is used to cycle through 3 banks of waves. That would be A, okay. Green is additive harmonics. So what do we've got controls of wave types. We have trigger, freeze, volt per octave, FM, and level. Those are outputs, I think, on the right. How do these people do this? Like, how do they do this? How do they do this? You have to memorize and get to know all of your modules. So when you see one of these giant walls of modules that represents somebody going in there and studying hundreds of pieces of equipment with all of this complexity, I don't know what I'm doing. So let's put this onto the bank. That's our control signal. And then somewhere here, we've got an output. So our control signal's doing that. This is the blue channel. The blue channel, we can put in a volt. That's an input. That's an input. High, low, uni, and bi. I think bi is everything at once, right? So there's our control signal. So let's get zoomed in on that. Oops. I'll keep that there. So yeah, that's plus minus 5 volts too. And just viewing it as a rolling wave. So we've got a variety of things doing. And these change the wave type. Now, that is below audio frequency, so I think I can slow things down. Yeah, there we go. So yeah, that's doing its thing. That's what Sheeps is doing. It's creating this control voltage. So I want to give that control voltage that we're creating and test to see that these channels work. Because there can be soldering issues with the PCBs on these. That's why I would like to control them from something reliable. So this changes the waveform. And if I put my low frequency oscillator into it, I can't tell if anything's happening. I can't tell if anything's happening here. All right, so if we do saw wave on this one, then this should be getting more and more smooth. Smooth or chaotic, I don't know which direction we're going in. It does not appear to be doing anything. We flatlined. He's dead. Oh no, there it goes. Okay, so I really should make a new front panel for this thing then, so that I know what does what. The poster's a classic. I saved it from an office that did not approve of my methods. I like that poster. I have a similar poster that my brother gifted me, where it's the electronics guy, the electricity guy holding up a kid with a knife, and it says, "Careful, you know, electricity is dangerous, or it'll kill you or something." We're so back. I don't know what the hell's going on. I have no idea. I want to know what 1, 2, and 3 do. EF shape slope knobs. Oh, shape and slope. Okay. CV inputs control the XY coordinates of the wave map. That would be... Is it those two? Which ones do that? Or these do the coordinates? Clock trigger input cycles through the 3 banks of waves. Wait, so if I put a clock signal into the clock, what's that going to do? The uni and bi outputs contain the same signal, but uni oscillates between 0 and 8, and bi between plus and minus 5. So if I go to uni, oh, that is between, I mean, that almost gets to 10 volts, as they say. Oh, 0 and 8. Oh, I see. So 0 and 8, and then this is bidirectional. So this goes for plus and minus 5. Oh, you guys aren't seeing what I'm seeing. Great. Good work, Bother. Good work. So this one goes between 0 and 8 volts. And then this one goes between negative 5 and positive 5, rather. All right, later, Carabos. Thanks for hanging out. Sorry, I'm not very quick. I'm not quick on the uptake like ever, but I'm especially not quick with chat today because I'm trying to learn stuff at the same time, and I am chronically stupid trying to just get my head straight about all this stuff. So our front panel is a little bit different from what we would expect. What is the What does D do? What do? So this cycles between the banks of waves and makes this one more or less wibbly in different little wobbly ways, increasing and decreasing the frequency of the wibbles. So we can make them nice and slow if we want to have a complex control of a knob. And then what does this do? Nothing. Nothing. I think this is the amplitude of the wibbling. No, because it's still doing stuff. Oh, now this is controlling the amplitude of the wibbling. You can see as we go up, it gets more varied over a variety of voltages. Shape, slope, knobs, and the CV inputs control the X, Y. So put our thing over to here. Yeah, the smoothness is, ooh, I changed back to the ramp up. So you can see it get more rough as our control voltage goes up. Now, in terms of tuning, I don't know. I have no freaking clue what to do with that. This is yes, it appears to be made out of some kind of a substance. I never get the interaction between the knobs and the control voltages. Are they additive? Are they subtractive? Are they multiplicative? Or are they a replacement? It's strange to me. The knobs still do stuff. I guess they're additive. And so you can add a positive or negative signal to where your control knob already is. And I think that's the way they work. But I think in software, especially with these largely digital modules, you can change all of that stuff. By default, the clock trigger input cycles through the 3 banks of waves. Okay, so the clock input, I have a pulse output that is akin to a clock. Let's go to the higher frequency one. That'd be the 0.8 hertz with the triangle wave. And then if we go into clock, which is the bottom one, there we go. It's my pulse is changing modes. You can see it's cycling through the banks of waves. I wouldn't want it to be that quick, but I guess, you know, whatever. Okay, I seem to have found something largely... But then, what the heck? So this is just about pretty much inserting some kind of musically timed weirdness into your system. These are well, I mean, they seem like they're getting close to audio frequencies, but if we compare it to an actual audio frequency, that's an audio frequency, right? That's a low audio, that's actually a C4. So that's the middle of the piano. Oh, I need to actually plug this in to USB, otherwise the waveforms are gonna be all weird. There you go. I don't know why that is. What's up, Nano? We're looking at Sheeps, the module that I'm currently... I don't know if there's a lot to tune here. I think maybe this thing can be held at 0 volts. Okay, that's audio. That one is audio. That probably sounds like crap, though. Let's be honest. Yeah, those look like audio waveforms. Okay. This is the quick rolling scope. So if we listen to this, if I plug this into speakers, we're going to get a symphony of horrible, horrible noises. I understand what you're trying to get at. I had to do a lot with C# on my senior design project for coordinating data going in and out of a flash animation. I didn't personally do it. It was a teammate of mine. Felt bad for him. He wanted to do Wi-Fi tracking, so he signed up with this professor thinking that he would do Wi-Fi tracking of like people in a building and stuff. It was like a pretty hot topic back then. And he ended up doing computer vision. And we didn't even do all the computer vision. It was a buddy of mine that did all the programming. I don't know what the hell kind of structure I could get out of this in order to do music, but it certainly could inject a lot of randomness. Let's get a module that actually can be tuned. I think the zero crossing is what the knob is for, and I think I've already tuned this one. What other signals do I have coming in here? These are outputs. High, low, and unity. Well, what's high and low? Oh, okay. Maybe those are inputs. Nope, they're just high. Okay, high and low. And then 1V per octave goes into that one. So if I take my 1V per octave, do that. Frequency does not appear to be going. Oh yeah, it is going up. Yeah, there we go. We're getting 1V per octave style behavior out of this thing. That would be for the audio waveforms, I would guess. For a very brief time, Microsoft tried to make Java. They made F#. Weird. Yeah, Microsoft's got to always do their own thing, huh? Okay, so I guess this one works. This could be like a cursed VCO, but it could also be something to wibble the knobs for you. So that's its role. And it appears to function. I don't really think I need to do much to tune it. When they say a signal is plus minus 5 volts, I'm seeing that it's staying within its bounds over here. So we now learned what sheeps is and how it do. I am going to graduate this module to the done pile. Writing in D. I enjoyed my brief stint programming Python. I think in physical computing, if you have a fast enough processor, you can do a lot of really interesting stuff with Python, especially if you're doing like an art project or something that doesn't require you to be pushing those ones and zeros really, really hard. If you're doing like a hardcore engineering project, I default to C. Some people, well, everybody scatters to their own, the language that they love. But I believe that the Arduino C can do a lot of really cool things if you peel back the veneer just a little bit in some places. Hello, what's up, Slendev? All right, so sheeps works. I don't understand it at all, but it works. And there's not much else to tune because it is not musically oriented. It does not have, well, it does have the 1 note per volt, but I don't think I can tune that outside of software. F# was supposed to be a functional language akin to the ML family Haskell. You guys know so much about programming here that I don't. I have no idea what you're talking about, and I will keep it that way. All right, who's next? Who dat doing that? Let's see. Well, we've got the 3340 VCO. This is a particular chip. This chip was made by some guy, and then that guy died. And when he died, the rights to the chip died with him. So these became extremely rare. Nowadays, a couple audio companies have, through the behest or the will or whatever, the surviving family members of the person, they have been able to negotiate remanufacturing these chips. So the 3340 VCO in a chip is now a thing again. And so whoever this was, oh, it's nonlinear. Nonlinear Circuits took one of those and they basically just built it. One thing I disagree with the way one thing I disagree with nonlinear circuits on. Oh, this camera's frozen. All right, we're gonna do this without the microscope today because the microscope froze because I bumped the cable. That's something we really need to fix. I would like to turn this into USB-C and have a screw-in USB-C on that so that it doesn't unplug. Disagree, it's functionally oriented, but has procedural and OOP. Oh, well, whatever. You guys talk about what you talk about. I don't know what you're talking about. I might as well be talking space language. The nonlinear circuits designs, they will put the entire part on the silk screen. In this case, it'll say like a value instead of that this is a resistor. So this resistor here is 100K. It has no other markings on it. It's not U1. I appreciate the U1, the C4s, because when you go to change something in your design and you say, wait a second, if you want to modify this thing to become a low frequency oscillator, you just need to change these parts. And you say U4, change C4, change R4. And everything else physical remains the same. If you put a value down and no associated U, C, or R value, how do you change parts? And so nonlinear circuits has dealt with that. Now, nonlinear circuits, by the way, nonlinear circuits has created a new module every month for some time. So I don't totally fault them. It's just, I wish they would retool to do things the proper way. So here's the deal. With all of these things called out the way they are, nonlinear circuits has to actually take a screenshot of the board and say, hey, this one right here, you need to change. So that's a little bit of the fault in this style of design. Other than that, nonlinear circuits make some pretty cool stuff. I've got two of their boards, this one and the one sitting behind it back here. So this is a 3340 VCO. It's a pretty straightforward thing because the 3340, the chip itself, was designed to be a voltage-controlled oscillator. Everything else is just how many inputs do you have to the different control bank channels. So we're going to take a look at this one. I've already tuned this. Tuning takes the form of jumping between two frequencies and tweaking potentiometers. So I've actually got a couple potentiometers here. I've got one of these multi-turn scientific ones, and then there's one here and here. We'll also take a look at how to tune it though, because, you know, I think this thing could benefit from having a tester. Now I'm plugging this thing in live. I shouldn't do that, but I'm going to do it. There you go. I heard a popping noise from something. Anybody heating up? Just the usual suspects. There will be a little bit of heat inside of the op amps, and the 3340 I think will just get a little bit warm. And let's just get it fully mounted so that I can plug stuff into it without worrying about it breaking. The plastic is strong, but I don't want it to, I don't want to press the issue. They're having a whole conversation about. All right, so the 3340 is, I guess I would count it as analog. I don't know how it's creating the oscillations. I think it's just in the structure of the transistors and whatever the die has configured. And it takes up a lot of space on the rack, so I don't know if I necessarily want to use it, but I do kind of want to have one of the synthesizers be mostly analog. And then I can try to make a minimal one to travel. Julian desperately wants me to get this thing working so that I can take it over to his house. All right, output. Let's see, that we're monitoring our control signal. So we'll do output on blue. Let's take a look at the hardware itself and what it does. So this is nonlinear circuits. 3340. Hopefully, they have a little bit of information available. Phase modulated sync pan and pulse outputs based on the Aries PMS 338 VCO. Oh. And they have a video. I don't want a video. I want you to describe to me how it works in text. Well, we at least know what's going on with this. So we've got coarse, fine, logarithmic FM, so a frequency modulation. We have an edge selection switch, PW and PWM. We have pan, although pan PWM, triangle sine pulse saw, soft sync mod, and then sync, and then CVs. All right, let's take a look. No clue what you're building, but it looks fun. We're tuning. Oh, I thought I turned... Oh, that was Streamlabs. Sorry, I meant to turn this one off so you guys could see what I'm looking at. All I'm able to do is look at the front panel. I really could use a tuning manual on this thing. Does Eurorack module from nonlinear. Yeah, the thing about the nonlinear circuits is they lead you back to this page, and this page doesn't give you a lot of information. I'm sure watching this thing, you probably would get it a little bit more, but... Marketplace, pictures, buy it on Reverb. Okay. Nope. I could use a better front panel on it. We got to figure out how to make my 3D printed front panels work, though. This is, yeah, the CEM3340 just has you configuring things like this. That'll get you all of your inputs and then your outputs. It's a neat little solution if you're looking to make a VCO out of a chip. I thought I had a tuning guide on this thing. Check the data sheet. It's very likely you can't drive headphones from the square wave out. Okay, I'm not looking at that. That's a different, they asked a different question. All right, let's just take a look at the module then. Let's just take a look at the signals that we're going to get out of this thing. I need a tuning fork. Well, I'm going to trust that this scope is able to give me the proper representation of frequencies. The sine wave output on this thing is 261.63. Oh, is there a green light? Oh, that was yellow. 261.63. And I looked on the scope and I got between 240 and 270 from this thing trying to create that same wave. So I think it's okay. Let's see, this would be a control voltage. Output is, where's that front panel? I gotta have the front panel open in a different page because I can't read my own writing here. I needed to find a better marker. PWM pan, this one is pan, pulse, try, and sine. So pan pulse, what the f... I'm gonna take all the knobs to the center position. All the knobs to center-ish. Now, some of these called for a ball detent knob, where it has like a setting that it can, where it'll stop basically in the center. I don't have that. I don't have that ball detent. Okay, so coarse tuning and fine tuning are these two. This is how you change the waveform. 1 volt per note. Where is that coming in? Initial phase, mod, and then this is the edge. And I guess that changes the edge that you're going off of. So if I take this pulse and I put it into sync, you can't really see anything happening. Let's zoom in a little bit. We're not triggered on this channel, so it's going to kind of jump around. Change the edge. Doesn't do anything. Okay, so this is the PWM channel. So if I put this control channel into the PWM, you can see it's altering the length of my PWM. But it's not doing it fully, it's doing it only to a certain degree. Now what does pan do? Because I don't know what panning, oh, pan moves it on the number line. So there we have it on 0. Too far up, that's too far down. Somewhere in the middle, just right there. Okay, that's that one, that's confusing. Pan PWM. I don't think that's doing anything. Oh, that's for the control, I'm guessing. So that's the PWM signal. if we do the pulse, or sorry, triangle. This one's triangle now. We're not controlling anything on triangle. Okay, I'm starting to get it. It's becoming slightly more clear to me. Each of the waves have properties, and the properties are being controlled by the knobs. The initial phase and mod and edge, those are going to be off of some kind of a sync signal. So if I take my very slow sync of the high, low, low, high, not sure what that's going to do. I don't think it's doing anything at all. All right. Let's sync out of there. Get him out of there. Okay, so 2 CVs can come in there, and those, the log or linear, which one? I guess log and linear are the other knobs that we're taking over by putting in CVs. Which one does the note? Soft sync, mod, and sync. Line in or linear FM and log FM. And then 2 CV inputs. So let's see what happens to the frequency if we put our triangle wave into a CV. Okay, so that is definitely altering the... Oh, we lose some amplitude there as it gets too high. That's the response from CV. This is log. So we should see it changing frequencies at a different rate. Let's just go a little faster. Oh no, not louder, faster. Faster, this one. I meant slower, sorry. Just so that you can see the change in frequency on the wave. You can see the... Yeah, slower even still. I don't think we'll be able to see it though, because it's too high frequency. If I go to where it's rolling scope, all we can see is the amplitude because it's all crashed up against itself. Brink GG! GG! Nice beard, sir. Thank you, sir. I wish I had one. Get growing. Brink GG subscribed with a tier 1 for 25 months. Gotta love holiday weekend half days, oh bother. Oh yeah, it's nice. This is always nice to go home early. All I see is the effect of high frequency on the amplitude of this. I can't really ascertain what frequencies are coming out of it. Now I can still do that with the scope. I can turn the math on the scope, but yeah, Brink GG, thank you for the 25 months. Okay, so the next one would be linear FM. Nah, we can't really see anything happening there either. Oh, I put the wrong thing into it. No, I put the right thing in. We should be able to see it. Well, linear FM appears to be doing nothing. I always hit the wrong knob on the scope, sorry. Show me those triangles. Yeah, it's still nothing. Oh no, it's changing. It seems like this is the fine adjustment, whereas this would be like this is 1 volt per note, and then this is some kind of a logarithmic FM. Why did I feel things? Why do I feel things when I touch that? Is there a voltage? You guys might be able to hear buzzing when I do this. I want some advice. I'm 17 and I want to be an electronic engineer. I do not know what to tell you, man. By the time you become an electronic engineer, the whole landscape is going to change. Things change constantly, and I can't keep up with it, and I don't know what advice to give a 17-year-old. I know you have to choose your whole life right now, and I said the same thing. I said, I want to be an electrical engineer, and then all kinds of weird shit happened, and I have no idea if I made the right choices or not. You are going to have to get familiar with math. You're going to have to learn how to learn. That was the worst part for me, was learning how to learn. I don't have an attention span. I'm sitting here talking to you guys. I'm on Twitch. I have ADHD. But, you know, it's just a thing. Learning how to learn was very difficult for me. So this is the three here are synchronization. These three are the inputs. So I'm actually going to get a Sharpie and draw some lines on this so that I understand that what these things are doing or what they're doing. I'm going to get a big marker. Oh, that's really bad. And then this one's PWM. It's not linked to anybody. And then these are linked. These are linked. All the way up. Offset. PWM, pulse, triangle. I've already got writing on this, but it's faded out. S, saw. So CV, linear. And then this one is, oh no, that one's log. Oh no, 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 it's permanent. My dog is making a racket at the door. I don't know if you guys can hear the barking. Log and then lin. So yeah, it's modulated depending on the voltages that go in there. The only buzzing I hear is the constant state from my two brain cells bouncing around and rubbing together. My brain cells. Okay, sorry, let's reread because chat's being encouraging. I sure hope Bother doesn't instruct me to grow a beard. If you can't grow a beard, fine. Ohm's law and Kirchhoff's laws never change, not even once. No, I mean, look, the fundamentals of what you will be learning are, but they're different because, like, we learned a lot of like analog stuff that just is not used anymore, right? And no, I don't mean to be discouraging. I'm just trying to say that I'm not, like, I can't give you great advice. It's kind of crazy. I think most of us here are quite happy being saddled with EE knowledge. Yeah, that's true. That's true. No, and getting to know the electrical engineering stuff is great. Learning how to learn was my biggest difficulty. I was not good with math, and I'm still not good with math. I just am, and if you are the type of person like I am, and you like poking stuff and having things respond properly in the electrical engineering space, then good on you. Go into college for it. Yeah, there's certainly lucrative career paths within all of that. People like you are my inspiration, want to be like you. I'm good at maths, but my physics is not up to the mark, and so is my chemistry. Most engineering physics knowledge is just good enough. You don't, yeah, you may not need so much physics. You will, I mean, the introductory classes, of course, will cover stuff in lower detail, but yeah. Start doing projects and breaking things. Make mistakes. Learn what not to do. Yeah, those are the lessons that stick with you longest. Take stuff apart. Take a look at the circuits. What is this thing? There's a part number on it? Look at the part number. Look at the data sheet. Oh, cool. What does this part do? Oh, this is a thing. I see now. And then in terms of like introductory stuff, I'm not sure what to recommend. I mean, I cut my teeth at a young age reading Radio Shack books. You can't even find a Radio Shack now. So being interested in projects like this and sort of doing a little follow-up on it and figuring out how they do what they do and why, and finding the channels that will tell you that is sort of, will hopefully build a foundation of confidence that you can rely on when you're studying this stuff. It's like mechanical engineering, you can get into a ton of shit. It depends on what you get into. I think EE or computer engineering can get you into a wide variety of stuff. That's true. That is true. Yeah, it's, you know, it's all water under the fridge, I guess. There's the book. Yeah, if you want to actually read the book that taught me electrical engineering, the problem with the book is that digital electronics weren't what they were today when that thing was written. Nowadays, digital electronics will get you there, man. You can buy a cheap kit and start programming an Arduino to do stuff in the electrical engineering space pretty quickly. And so I don't really know the best way to bolster that, but certainly there are thousands of directions you can go in. Find something that you're gonna retain interest in in terms of like how to get familiar with this stuff. A lot of what we're doing is like bench work and lab work, and that's something that I've learned over many years of smashing my face up against the table, how to kind of operate a bench and do all the different functions that we need to do. Why is nothing happening there? Why are not due? Oh, because this is our control signal input. This are due. There are due. So there's due. We can't listen to do right now. The link died? Ah. Shame. Yeah, dead link. We got to fix that at some point. Shared hype trains are a thing. Oh, God, shared hype trains. When are we ever going to do that? That was an MIT link. Oh, son of a bitch. Forrest Mims, Getting Started in Electronics from 1994. So the CEM 3340 would be something that I would potentially use with the middle bank as I have coded it. So the middle bank on this thing does the VCO tuning. I've got a C4 note, I've got the note being output, and then I have a DC voltage level coming out of this thing. So what I'm gonna do, free up my channel here, and we've got a sine wave output, which is looking a little janky. I don't know what's going on with that. That's not a PWM thing. Oh, the initial phase should just slide it back and forth. And then the mod here, what does that do? Nothing. Does nothing. Man, I do not know what I'm doing. Okay, so I'm going to take my voltage and I'm going to put it into linear. And then I'm going to observe a C note. It's not even close. It's not even close. Wait, it's not even close. Yeah, I made this plus minus 10. I probably should have taken the amplitude down a little bit. All right, put that there. What is this one doing? Log FM. Okay. All right, so we need some math channels on this. So math, and then we'll do, wait, what's that? That's not the right menu. Get rid of that. Measure. And then we're doing a horizontal measurement of the frequency of channel 1. Well, we can just go straight to channel 2 because comparing them like this doesn't really work all that well. So if I take this to the prescribed frequency, 261.63. So that's really... Okay, so we'll use fine tune now. 261, and I don't have much more resolution behind that. This thing gets a little jumpy. See, what musicians actually do is beat matching, where you listen to both of them at the same time, and the waves will actually sync up with one another and produce what are called beats. So when it's 180 degrees out of phase, it'll actually cancel out the wave. And this is what musicians listen to when they're singing and hitting the note at the same time. Meh, 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 meh. And they listen to those beats and how frequent they are. And you can get it so that there are no beats if you're really, really fine-tuning a frequency. But in this case, I mean, if I add these onto one another, They're not the same amplitude, though. They're not the same amplitude. I would have to reduce the one coming out of my thing, which I could maybe do with this. Yeah, wait a minute. We can do that with this. So I've got another module here, and this thing is it's actually an attenuator for outputting your signal. But I think what I can use are these back here in order to, excuse me, tamp down the volume on this thing. So I would be taking this signal here and reducing it. Yeah, nothing. Oh, wait, no, I can't see it because, wait, what am I doing? I'm taking that signal there, taking it over there, reduced, and then I want to mix it back in later, but it looks like my assumptions about how this thing works were wrong. Darn it. It's reducing it by so much that it's just not visible. Wait, what's going into blue channel is from the synthesizer. Oh, I have that. I see. I have that at a different voltage. Wait, why is that so... It's like the range of my vertical changed. Strange. No clue what you're building, but it looks fun. We're tuning synthesizers. Yeah, the attenuator's too much. I need a very slight attenuator to change that. And I could just go into the programming of my module testing module and turn it down so that it matches. Then I could show you guys what beat matching is all about, because you can see there, oh, they synced up somehow. Oh, we're moving a little bit. Our frequency is slightly different. Let me show you guys this, because this is actually, if we're thinking about like what we're listening to, these two will cancel out in the air. So let's tamp down. I keep using these words. Let's tamp down our signal so that it matches the output audio from this device. And that involves going over to the Arduino code and just going down to wherever I'm making that waveform. So this is waveform sine and waveform pulse. Let's take the amplitude. So I'm actually, waveform pulse is what I'm using to create the DC voltage level for this particular frequency. 261.63 at 0.99. We'll turn it down to 5 volts. So let's take it down to 0.5. Is it a 0.99? I put down 0.5, and then I have to upload the entire piece of code. Luckily, our Arduino's plugged in and ready to go, so. You don't need to be an expert in all these topics in order to be an engineer. That's very true. That's a very sad sine wave. Hey. Yeah, and especially this day and age when you can just look anything up. It's like, you're not going to be able to look this up when you get into the field. It's like, well, yeah, now I can. Now I have to use ChatGPT for it. Oh boy, when does the AI revolution start affecting big projects? When is our infrastructure going to start crumbling because of vibe coding? The vibe code said it could take that load. Oh no. You didn't pay the phantom tax on that bridge. Ugh. All right, so we got our code up here. Nothing much has changed, except, oh, our amplitude is way less. If I go to channel 1 and I zoom in on it a little bit, here we've got our 2 signals. Looks like this one is a little bit hotter than that. How do I turn you down? Hold on, let's see, what do we got? How do I turn you down? Phase, fine, PWM, pan, initial phase, and mod. And then I have an edge that I can sync with. Okay, so anyway, the point is, if I take this signal, and instead of applying it to our scope channel, I apply it to itself over here, we should see it canceling itself out. It doesn't really appear like that's what's happening. If I go to the fine adjust, no, that doesn't appear to be what's happening. I thought they would cancel each other out, but it appears to be overwhelming something. I thought that the two outputs going at the same time, I guess because they're in amplifier circuits, they're not isolated and they're feeding back on each other. Yeah, that's probably not working out. Darn, I was hoping I could show you guys the two waves canceling each other out. I can sync it up by going right and left with the fine adjust. This is near enough as makes no difference. I think this would probably sound like a C note. So what happens if I then go to another note? I've got that plugged, programmed into the module. Boop. Oh, the response is completely different. So yellow is my comparison, and that should be what that frequency looks like. It looks like it didn't change at all. Yeah, even in logarithmic, it doesn't change with it. What about you? That's high and super high. This thing sucks. Funny, I can actually hear something when I flip that. When I flip that, I can hear a humming. If you play it, we can probably hear it. I don't want to play it. I get very annoyed at stuff like, you know, constant noises or too much of a repetitious pattern. The musical brain in my brain goes brainy. Yeah, so I'm operating it on this scope over here while you guys can see it up on screen. These waves are very closely matched at the C note because I twiddled the knobs. The problem is, this is a musical instrument. 1 volt per note should go into, I guess, the CV input. I don't know what the scaling is like on the CV input. But when I put it in, yeah, it's got a completely different response. And that's down to the knobs. I can tune that with the knobs. So I guess I need to get a set of adjustment things here. These are those little stand-up potentiometers on the board. So I got this guy to adjust that with. There's also one right here that I don't know what it does. So let's take a look and just see. Maybe non-linear circuits 3340 tuning. All you get are people asking questions. Druid, blah, 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 blah. Circuits powered plus minus 12 volts. Built part of the surrounding. Oh, God. Tuning an AS3340. Oh, hold on. Nope, got to get out of there because it'll reveal my emails. $3340 tuning notes. Oh yeah, this is actually a good source. That's why it's all zoomed in, because we've already read it. That's 4 trimmer. And I don't think we have temperature compensation circuitry on this thing either. Let's just see what happens if we start tweaking it. Well, this one's already pretty much, well, in the position that it's in. We need to do the linearization of this thing. So that means that we get it as close as possible to a C note here. And then we go to the A note, and then we get it as close as possible to the A note without touching the knobs. Wait, is that top knob? What is the top knob? Oh, coarse and fine tuning. Yeah, okay. So yeah, that's largely this way, you know, when I send it a certain voltage signal, I'll know that I'm hitting the notes that I wanted to hit. Julian had a different perspective on this. He said that, you know, sometimes people want to get completely apart from sort of the exacting science of making this 1 note per volt. They would say the whole purpose of this is to just play around until you get something that you know, works for your purposes. I don't know if I can get this in there. Probably should have made the hole for the adjustments a little larger. Maybe a flathead will get in there better. I don't remember this part of building this thing. Okay, this is a frequency. Okay, so I'm going to get this as close to 261.63. Which, with my scope jumping around the way it is, that's about as good as it gets. But I could also stabilize it so that it's not traveling horizontally when it's synced up. Ah, that's how we'll do the fine-tuning. So if the blue signal is motionless, then I have this at the right tune. It's moving a little bit to the left, a little bit to the right. Just a little bit up, now it's moving left. We are essentially sort of visually using beats in a way. Kind of cool, right? We're too dumb and engineering to be good musicians. So instead of listening and hearing the cancellation of the two waves, we are looking at its linear motion right and left in synchronizing with the wave that we know, which is the one that's being produced by this module, by the testing module. Weird way of doing stuff. It's a very weird way of doing stuff. Yeah, this also, whoa. This is also altering the frequency. So we get it, let's get it tuned back up to C4. I shouldn't have touched that one. I should not have touched that one. Why can't I get the flathead into the thing? There we go. There we go. Okay, it's stabilized. Mostly. That's pretty good. All right, so now we go to our second note. Dude. This should be a much lower frequency. So I'm going to go up here. This actually does not have a lot of adjustment to it. This is a 180-degree potentiometer, so I can't get it down to where I need it to be. So let's take this down. This is not going to go far enough. What about you? Nope, that doesn't do that. Well, here we have our first problem. I can't get down to A0. Now this, I think, is a 25-turn potentiometer, so... Ah, it just clicked. Nope, can't get it down there. Later, Poopsie Doodle. Okay, so first problem is that the range of control voltages that I'm putting into this thing doesn't appear to really affect it the way that I want to. I mean, if I put it in the CV, whoa, that is a huge range. My sine wave looks better. So we want it to stop moving. What is the center of these two? Hold on a second. Take this back to the center. Yeah, the center for that one is over here. Down, all the way up, and then center. There. So now I should be able to bring this to A0. Well, that only goes up. That should be in the center then for the beginning of our test. That's not quite working out, huh? Yeah, that's not going to give me enough adjustment. What does this one do? Oh, that just has to do with the effect of it. We got the hovercrafts coming by. All right, there's no hope of hitting A4 unless I do it this way. want to do it until this stops jittering around on the screen. It needs to stabilize. Although I might not get it to stop more than doing that. Let's get a little more information on the screen. That's a little less rickety. All right. Did you say hovercraft? Yeah, they're practicing for the hovercraft races. Yeah, it's the neighborhood's yard work being done. Why do you not stabilize? Well, it actually appears like it's the wrong frequency still. This one should be, let's use the scope, 27.5, and right now we are at 24. Okay, so I need to go up. 27, that almost stopped it. I don't know how to get this potentiometer into the middle. There's the click, so I'm gonna go 1, 2, 3, 4, 5, 6. Let's have it 25. 7, 8, 9, 10, 1, 2 and a half. There. That's in the center. Okay, so my 25 turn potentiometer is in the center. I can't really tell where these are. I'll just go to one end. And then the other end is, it's like here to here. So I'll take it out a little bit like that. That'll hopefully be in the center. That one doesn't do anything. Okay, so now I need to sync it up with A0. So we need to tune this down until we get to A0 as close as I can. 6, 27. That's about 27. See if I can fine adjust it as well. With the adjustment knobs in the center, I want this to line up to my lower note. And then we can take it to the upper note and see if, there we go. Yes. Look at us. We're doing music. Oh, look at how stable that is. Awesome. All right. Good, good, good. So this is non-musically tuning musical stuff. I have a control voltage coming out of my tester, and I have a frequency coming out of my tester. The only reason they're synced on top of each other was because I was able to manipulate it with this knob. But as I change the frequency, they fall out of sync with each other. So what I want is for that blue one to stop moving. Yeah, mine hovercraft is indeed full of eels. Mine dicky old chum. Okay, so all the sync stuff we're not using. We're not doing anything with PWM. We have a triangle, a sine, and whatever other output waves over here. We have pulses and sols. We don't care about those. Right now, we're just syncing up our sines. And the sine that's coming out of my thing looks a little bit more sine wavy than the one coming out of the CEM 3340. But this is basically a VCO chip. We've got different voltage inputs that can affect what's going on. As far as I know, I'm guessing that we should use probably the CV, although there's logarithmic modulation and linear modulation. I don't know which of these I should actually be using. Technically, if I unplug this and put it in here, that should be, it's at a different frequency. I don't know if I need to be tuning it for frequency modulation for linear or logarithmic. 1 note per volt is pretty linear, I guess, but our notes, that's linear notes. That's not linear audio frequencies. I don't know how this thing works. All right, we're gonna go back to the CV. Let's just tune it up and see if we can successfully tune it for CV. So see, everything's synced up, everything's nice and happy. Now I go to my next note, boop, which is much higher of an octave than what we already had. We can see that our waves don't sync up. I cannot touch these knobs. These knobs are the basis by which you would tune this thing initially. I need to make sure that it responds properly when you've got these two knobs in the right place. Because if you want to do like, you want to tune it up like an octave above, then you can do that, I think, with the knobs without it affecting this, if we tune the rest of this stuff properly. So it's between these two potentiometers, I need to get these waves to sync up. And one of them is one of those hateful little surface mount jobbies that I really just don't like. So this should be 261.63. I can get it up to 261, but I don't know if this is the right way. $261. We can use this to just kind of get in the center there. It's close, not quite it. I think I need a third note to test it. We might have to actually make a third mode on this thing. Come on. Ugh. This is like a mini game. And then when you release, it might actually affect the results a little bit. Hovercraft racing is on around you. You mean the actual one? What we're doing is when we talk about hovercraft racing, we're talking about them mowing the lawn here. All right, so now I use this one. It's all two-stroke motors. And this should be 27. Let's get more information on the deck. Ah, no, don't turn on the veneer. I don't even know what that is. So this one should be 27.5. So we'll use the other potentiometer to get it to 27.5. Oh, this thing is bad. I do not like this pot. Give this a little tweak. Okay, and then back to C note. It's all messed up. Yeah, this potentiometer has no travel to it. Wait, 180? Oh, geez, I gotta move quite a distance here. I went the wrong way. We gotta go up to 220, 260. 255. Oh, I don't have any more travel. Son of a bitch. All right, I'm gonna have to come off of the edge there and see if we can do it with this other one. Ugh, this is a tough process. If I did a frequency sweep, would it be more clear how to adjust this? I think it's out of range. I don't have the range in order to tune that. Interesting. So going from A0 to C4, I mean, that's 4 octaves. That's not that many volts. But the CEM 3340, let's look up the data sheet and see what, not 49, CEM 3340 data sheet. See what kind of frequency range this thing can work with. Ooh, this is nice and old. This is a photocopy. CM3340, 3345 are completely self-contained precision voltage-controlled oscillators, featuring both exponential and linear control scales and up to 4 buffered output waveforms, triangle, sawtooth, square pulse, etc., etc. Okay, so large sweep range, 50,000 to 1 minute. I always love when they break out into different units for that. So the frequency can go from 50,000. I don't think it's 50,000 minutes, but the frequency, just saying a minute. That's pretty crazy. Fully temperature compensated. Oh, that's nice. 4 output waveforms, summing nodes. Okay, so frequency range. See, 10 volt, peak, hard sync reference voltage. So this thing can handle the lower frequencies, but what is the higher frequency? I mean, it shouldn't struggle to do C4 at all. And maybe the whatever the stuff that I was provided with, whatever the circuit is that I built, isn't able to do that. That would be down to the whatever amplifier it hits on its way out, I guess. Yeah, I don't really know what to do. This thing's kind of cursed then. So what happens if we try to do logarithmic on this? But it's like not changing at all. I mean, it's pretty close, so I guess we just need to keep tweaking around with it. I just feel like I'm running out of adjustment distance. Because, like, yeah, there, see, I can't get up to 61. Take this back in a little bit. There's 261. Oh, come on, where'd you go? Boy, I would advocate to put a 25 turn on this other pot. Although we wouldn't have come to conclusions as quickly. There's 261. Wow, I got really close there. Stop that from moving much. And then go down to the lower frequency. And that's supposed to be 27.5. So I'll take this other one. Looks like not affecting it at all. Let's try this. Wait, double check. This one does nothing? Yeah, that does nothing. Okay, that's adjusting something else. So, all right, back to the scientific trim pot. So I need multiple turns out of this one to go down. 30, 29, 28, there's 27. That was a significant amount of adjusting though, so it's going to throw the other channel way out of whack. Yeah, way out of whack. I'm out of adjustment on that one. Damn it. Huh. So what I'm adjusting is the slope and then I think it's a linear, it's either a slope or an offset. It's like two different adjustments that I need to bounce between. So what was it? CM3340 tuning guide. Oh wait, I think we already had that open, didn't we? Isn't that this one? Yeah. So yeah, we're trying to get the different notes. So we're going from A0 all the way up to C4. We're not looking at a huge range, although we probably should. I think it makes it easier. I could program in like C1 and C6 into the thing. Internal op amp, blah, 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 blah. Somewhere in this document, it's basically detailing what I'm supposed to do. Yeah. Power supply voltage, trimmer circuit, and it's like it's two different tunes that will adjust where the notes are. I mean, as it is right now, at 0 volts and at well, it's not 0, it's 1 volt and 3 volts. 1 volt and 3.25 are two voltages, right? So at 1 volt, we should have C2. We end up being close. Our line just needs to kind of line up. So as I go through, I wish I could see that line. If I could visually see that line somehow, if instead of doing it on the scope like this, I was able to have it sweep voltages and then compare it to what it should look like, that's something that I could maybe build. If I have I need something that would translate the frequency back into a voltage so that I could plot it on top of the waveform. That would be great if I could do that. Because then you could frequency sweep the oscillator and it would give you your line, and then you could use those adjustments to properly, like, I need to move the line down a little bit, and then it'll match up. And then that would make it so that you could use these separately in order to do the operation instead of what we're doing, which is bouncing between two voltages and then matching up the frequency. Well, how would I do that? I would basically need something in here that could accurately read back frequencies and then plot them on a chart. We need to go up in frequency. 261. Problem is this is gonna 40, 50, 60. And then we go down. Blap. And we're at 40 when we should be at 27 and a half. Oh my God, my dog is taking it upon herself to protect the house. 5, 6, 7. There's 27. Back up. And we're at 177 rather. So now we move down from there. We're going to match it up again. We need to keep going in that direction. That's not a good direction. 89, 90, 95, 200 gets us closer. Let's go back down again. I think if I ballpark it at first, I'll get a little bit more within, because it'll start getting more and more sensitive. 30, no, 29, 28, 27, eek. You can do it. 27. I wish I could make that number larger, but that's the number that I'm looking for. It's this one right here. So when that gets to 27 and the two kind of start lining up, we can jump to the other frequency, and then I can get a little, like a teensy bit more, I don't know, fiddly with the number as we go. 261, we're at 182. 92. This is too fine of an adjustment. It won't go any further up. Oh, because I'm at the end of the potentiometer, so I go to adjust it here. Oh, I was close. There. Oh, that was what I wanted. Back down. Hopefully this adjusts the other way to get to where we need to go. 33, 32, 31, 30, 29, 28, 27. Okay. 27.5 is what I'm going for. There's 27.5. Back up to C note. 173. We need 260 out of you. $90, wrong direction. 55, 69, 240. I'm at the end of travel. So I gotta go and adjust the other one. 40, 37. This is gonna take a while to get back to 27. That's too much travel. Back up. I feel like I just lost all my progress. Yeah, I don't know. I don't know what it is. Something is, something's whack. Is what I want to say. Something's crazy about this, and maybe it's the range, but getting the two parameters to give me a proper thing is very difficult. Plotting the frequency would be a really interesting thing to be able to do, because making it into like a point, like a chart, that's like a MATLAB program that I could whip up if I had those tools. The microcontroller could probably do it, and I could have it plotted on the screen, but I don't think I could have the overlay with the scope. Maybe I could turn it into like a sawtooth that followed the frequency. Printing out the value of voltage on a chart as it goes up, and then also printing out, or having it output the voltage and then output a representation of the voltage that it's getting in based on the frequency. So if I gave the Arduino some way to measure frequency relatively accurately and had it drive one of the channels with a linear output, with a voltage output. So I'd have a frequency in that would drive a channel, and then I would have just a voltage out that would do a sweep. So as it was plotting this basically sawtooth wave, you could see the frequency coming in as a voltage. That's an idea. That's another doohickey that I would have to do. I don't have inputs on this thing. I have I do have an I2S input like driving board that I want to use, and we've tested. I don't know how good it is at doing frequency stuff. You need to use a library to measure the frequency. What pins is that on? Because I could make that into like a separate module. It would be, so what that would do is that would give me an idea of what adjustment I would need to make. Because it's like a rise over run kind of thing, right? It's like an offset and a rise over run. So you could immediately see where that second line is and go, okay, the slope needs to change. Okay, now it just needs to offset. That could make this task much shorter. But I can't do it yet because I don't have any inputs plugged into this thing. So we're back to what I was doing before, which is just frequency, 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 frequency. This has to be 26, I believe. 27. .5. And this one, I feel like we're getting close. Why does that not change at all? Go back here. That one's not changing anything. Weird. $260. Whoa, too far. 40, 50, careful. 260. Ooh, that's too many turns. Take it down to 29, and then this one is moved. Let's move that just a tiny bit. Oops, careful. Wrong direction. 250, 39. Ugh. Down on that one a little bit and see if we can get this one back into whack. It's just a very strange process. To 11, 13, that's getting us close. 230, back to the other one. We're at 31, we need to come down to 27. Back to this one, 200. I'm not going to get to 260 using that. No way. Let's bring you to 260. $260 there. Then we'll use this one to bring us down to 27. 29, 28, 27. Back over to you. 160. That should have been a little closer. Six down from 37. Geez, it really wants to go to 37 every time. Yeah, but I'm not gonna have that much adjustment. This is crazy. I feel like I'm going crazy. Do you guys feel like I'm going crazy? Chat, am I going crazy? I feel like I'm going crazy. It just seems like I'm not able to reach the right frequencies. This is a very frustrating process. You jump from voltage to voltage and you adjust the slope and the offset basically of your line. So it has some weird operations where it's like, if I adjust this to be the right number by adjusting, let's say this is fixed like this. And so we drop down to the lower voltage note, and that should be here, but it's too high. So it's like up a little bit. And so I adjust the slope to get it to be a normal note that goes down like that. And so then I give it this voltage. And so the note should be somewhere on that linear path, but now it's completely offset. This thing is in a weird spot. It's tough. It's tough. Maybe this is better visualization. Snip. Citizen snips. Actually, wait, I can just copy this. And then MS Paint. Yeah, so the two knobs are changing the slope and the offset of the line. That's what I'm pretty sure what they're doing. So it would be like knob 1 changes this, and knob 2 changes its position. Right? So I'm able to change both of those parameters, and I have to line it up on this. So I'm going from here to fa ti to la sol la ti do, do re mi fa. Where's A0? CBA is CBA. They're like back here. Although I'm going from 3 volts, or from like 1 volt. I think my volts are 1.0 volt is A1, right? 1 volt they say is C2. Do I have the wrong notes? Hold on a second. By establishing a standard control voltage to frequency system, it is possible for a discrete input source, such as a keyboard, to drive the VC input and produce exact musical note frequencies. It is conventional to define a control voltage range of 0 to 5 volts, corresponding to the music note range C1 to C6. This implies exactly 1 volt per octave. To produce middle C, 261.3, the control voltage would be 3 volts. Okay, my scale was wrong. My scale was wrong. Let's make sure that my scale is properly done. My scale was wrong. That's on me. Let's redefine in the Arduino what our voltages are. So we'll do C1 to C3. So sine, that's C4. So this one will be tune C1, and this one will be tune C3. Well, they say C1 to C6, but we'll do C1 to C3. And actually, I'll add another one, so that we have another case here. Oops, hold on. I'm hitting all the wrong buttons. And this one's C6. And since we're adding one, I need to add one up here. The middle mode has 1. Oh no, that's the wrong one. 2, which equals 3. 2 cases, which is 3 cases. So 0, 1, and 2. C1, C3, C6. So we can just do that jump. I'll just have to hit the button twice. Seems like the knobs both control one thing. It's rise over run and then offset. It's like tuning the high and low jets on a racing 2-stroke. Yeah, it's because what we're observing is not, I don't know how to explain that. We are adjusting something that could be observed by performing a frequency sweep. That's what I do. It's hard to put into words like that. I could build something, if this had inputs, I could build something that would create that chart of frequencies versus the voltages. But I would need to be able to receive frequencies and interpret them over the amount of time that the sweep was taking. So this is C1. C1 is 0 volts. Is that really where they want C1? Control voltage would be 3 volts. Each octave is divided into 11 intervals, which correspond to a control voltage of 1 over 11. So 0.909 volt per note. Wait, 0.9 volt per note? I thought it was supposed to be 1 volt per note. I get what you're explaining. I'm skeptical that the knobs are actually doing that. I saw a little bit of hope there. It seemed to be syncing up a little better. You know, the more I was fiddling with it, the closer it was getting. It's just that I ran into a range issue, and it seems like I don't know. We'll have to hold on. We got to investigate this. My understanding of 1 note per volt was, I guess, a much higher range of frequencies. But if I tuned it with this guide for the AS3340, that's weird. Other things I have say they're 1 note per volt. And yet, for some reason, this one says that it's... Let's see what we can find out here. Oh, let's see what AI has to say. The term not per volt. Okay. Everyone's a critic. 1 volt per octave is what it is. Oh, 1 V per oct. Okay, that's different then. Does anyone have a link to the table showing volts per octave? And there it is. 12 semitones, 1/12 per volt. This is 1/11 for a control voltage. Oh, there's too much information. I'm dying. Semitone is the difference one key and the next on your keyboard, both black and white keys. The standard synth, thanks to Bob Moog. Yeah, Bob Moog came up with this. 0.41 times 6 V. What? Oh my God. Let's go with what the 3340 says then. So we'll want to do, like, I don't know, let's go C2 to C5 because they're both positive voltages. I don't know how much I trust this thing to go to 0. So C2, C4, and then C6 actually, 2, 4, 6, right? So C2, C4, C6. C4 is a little bit more pleasant of a note anyway. So C4, sorry, C2 is at 1 volt. So that's 0.1. See, that one starts at 47, this one starts at 46. I could start it in the same place, but what I should do is start it at 48, because that'll center it a little bit more. 1 volt, and then the next one is, oh, whoops, no, I messed up. Leave that. It's not 261.63 though. C4 frequency. C3, C4. Wait, C4 is 261.63. .26163. Can't put hertz on there, it doesn't fit. So apparently my C3s and C4s were even messed up. Actually, I've got music note to frequency chart over here. C4, 261.63, okay. So our C2 is 65.41. C2, 65.41. Do we have room for hertz? Well, if I get rid of the 1, but then I won't be as exacting. 65.4, that's C2. C4 is 261.63, and then C6 is an excruciating 1046.5. I don't know if that's going to fit. 261 barely fits, so maybe I just do 1046. Ugh, I wish I could. I'm going to do that, and the text is probably going to spill over from the box. Wait, did I just see something move over here? What just happened? Huh, I thought I saw something slide in and out. Weird. I'm starting to go crazy. Okay, so 1046.1. And so the frequency, 1046.1. Oh, no, not on the DC. What am I doing? It's down here. 1046.1. Sine is 261.63. Why is that yellow? Is that how it should be? Yeah. Okay. And then up here we've got 65.4. Amplitude at 0.5, amplitude at 0.5, amplitude at 0.5. For the DCs of those, accordion to this thing, C2 is 1 volt. So this here, amplitude of 0.1 translates to 1 volt. C4, 2 volts, 0.2. C6, 5 volts, 0.5. Or roughly half amplitude. Okay, so that should give us the 3 modes now. And they've got all the right information in them, and it's possible that oh, wait, what? Huh? Hold on, I messed up. DC, 5 volts, 1046.1, 46.1. That might not fit. And then 0.2 DC 2 volts, 261.63. So weird. I could have sworn that well, anyway. DC 1V. And then we're centering that somehow. 46. Those are all 46, and we got one space in front of 5. 46, one space in front of 2. Position 48, 1 volt. So back to 46, and we'll 1.0. And we'll space that over there. Man, you know, making this thing look boring, like none of the text moves around, is actually fairly difficult. I could just sort of slapdash and not really do this kind of check that I'm doing right now to make sure that all the text is in the right spot. And when you hit the button, everything goes crazy. That would be much fun and much more fun looking, right? I really wish the dog would stop barking. 0.1, 0.2, and 0.5. So those will be our 3 points that we'll observe. I'll mainly go from 0.1 to 0.5, or 1 volt to 5 volts. And we need to double check that this thing actually does that. So let's upload that code, and let's see what that looks like on the scope. I think it's mostly pretty accurate, but if it's off, then my tuning is going to be off as well. I got to think about that, though, having the thing be able to do a frequency sweep and just showing me the line. Is it done? Tune C2. All right. Tune C2. Oops, wrong one. We're going to that one. So we got C2 on the clock. And now this should look like... Well, it's not... Oh, I see. It doesn't get that yet. Plug this into there. And then we got the same wave going into both. Ugh, it's got a weird cutoff because of the... I guess it doesn't like channel stuff here. Take that out. Oh, now it's nothing. What? Yeah, it should be able to observe the same thing at the same time. Oh, but it's not... No, this isn't outputting. We're just looking directly at the waveform there. So if I just yoink this, put this in... 65.483, it jumps around. Let's look at the voltage, though. So that should be pretty steady at 1 volt. Let's put up a measurement. V average. VAverage. Negative 42 millivolts. I mean, I could tweak that, but I think that's sort of within our parameters. So if I hit the middle button, we go to a theoretical 2 volts. Why are you at 43 millivolts? What's going on? Oh, it's measuring C1. Oh. Here, hold on. Oh, God, where's the channel on this? There it is. Channel 2. Oh, get rid of all that. That's way too much information. It didn't change channels. You little bastard. Channel 2. What? It's not... You know what? You know what? You can just go away. You can just go away. Oh, you can just... You can drag them off of the side. That's interesting. Measure. V average. Source. Channel 2. There's no like OK button, which makes it a little awkward. Okay, 800 millivolts, and it says it's at 1 volt. 1.7, 1.8 volts, and then 4.6 when it should be 5. So this channel is adjusted by one of these, and so I can affect the gain a little bit by tweaking it. Not that one, it's this one. 4.6. 4.4. Hey. What? No, other way. I'm adjusting my adjustment for the adjuster so that the adjustment can adjust the adjustment. 0.95, just a little bit more, a little bit less. Back it off, back it off. Let the average do its thing. I am chasing 9s, but I would like that to go down from 5. Oh, I'm off of the knob, that's why. 4, 3. They all seem to be off by an equal amount, which is why I'm adjusting this instead of tweaking it in software. There, 5.00. 900 millivolts. Okay, so I do need to adjust these individually, I guess. 936 is very close. 1.95. And this should be almost exactly 5. $936. We've got 0.07. So that would be this one. Wait, which one is that? We are currently on 1 volt. So C2, top one. And that's got 0.1 plus 0.007. I don't know if that's going to have... Well, it's not in a linear effect, so let's just do 0.01 and see what happens. I should probably put like a knob on this thing and have it like assignable so that I could make sure that my tuning equipment is within tune. Everything's got to be difficult, huh? $1.03, that actually did it. So what if I 0.005? Is that even gonna is it even gonna be able to do that? .007. Let's see if it does that. I just want to know what my my units can be. How fine can I tune this? And then it's going to be like a cold day the next time I try this, and it'll be a different voltage value entirely. Hopefully this PCM output is relatively stable and accurate. $1.006. I'm willing to accept 2 decimal places, seeing as the number jumps around a little bit. I could probably try to do a little bit more, but I think that's pretty good. So where's our 2 volts at? 1.95. That's going to be a little bit more of an adjustment there. So it's 0.2 plus 0. Let's do 0.05 and see where that gets us. Because 1.95 or 0.05 instead of 0.07. So actually it should be somewhere near the same value. So let's try 0.01 to start off with. 0.01 is going to be actually a major difference. Let's just see if it gets us closer to 2 volts exactly. Still compiling. Yeah, it's unfortunate. I mean, if I could do something with like serial commands, I could have it so that I can alter these settings on the fly and not have to reprogram it every single time. Oh yeah, we need to go up 1. 2.05, huh? That means we went up too far. So now I need to go below 0.1. So 0.009, 008. The other one was 0.007. The other one is 0.008. That's why I said it looked like it was linear. They looked like they were linear. Me being a meat-brained human, pattern recognition goes burr, but I wasn't quite right. They were very nearly linear. The problem is I don't know if this needs to be done with frequencies as well. Okay, 1 volt. Got pretty accurately 1 volt. 2.03. Ah, let's take that number down. Let's do 007. 007 on that one too. I'm going to hit upload and just immediately throw it into the microcontroller. Oh, it's already 4. Ah, it looks like we're out of time today. Let's just get this software in there and see if it can do a slightly better job at linearizing this thing, at getting this thing to actually match the right parameters. So now that we have accurately, we have 1.0 something or other volts, 2.02. Oh, that's so close. 5.00. 02 is unacceptable. I need to get closer. So I'm going to put this one to 6 and hit upload. We'll have to come back to this. Maybe we'll do it tomorrow. A little bit more of this. I got a lot of viewers today. I don't know why. Well, in the middle. When I was actually on camera. Yeah. The turbo encabulator. Reciprocating dingle arm. Oh, it uploaded. Oh, okay. So, wait, did it upload? It's still on 2 volts. Did I hit upload? Yeah, oh, it's still compiling. It's going slow for some reason. Compiling. I don't know why it took so long. There it goes. Yeah, everybody's leaving work early and screwing off. Yeah, that's true. It's funny how, in spite of my exiting of the workplace, it still affects me in every way. 2.01! Oh my God. So if I go to 5, maybe I can do 5. I'll just do 5 for now. Let's just see if that gets us to 2 volts. It's going to be like 1.996 or something like that. I'm not, like, all the numbers are swimming around in my head, so. I feel like if I really want to get fiddly with this, I could really make these solid voltages. And my my oscilloscope has been calibrated recently. It can calibrate itself, so it should be pretty heavily accurate at this moment. Did that do it? Did it? All right, so where are our voltages? We have 1.008. Ah, 2.005, hell yeah. And then 5.007. I've got 2 decimal places. I don't know how many decimal places the voltage should be in order to be musically accurate. If it's, I mean, what are they saying? The distance between notes is 0.09. Ah, so I might actually need a little bit more accuracy on this. Yeah, I think I might need to go further into the 9s here. 1 more digit into the 9s. How hard can that be? This is important work that we do. But if we get into the 9s right now, I am going to not make it to see my friends because I need to go walk the dog and everything. So I'm going to do that. You can make a flawless robot hand with Meta's EMG wristband that you got off of Tesla Optimus hand and hooked it up. I don't know what the hell are you talking about? What are you talking about? That is a very confusing. Anyway, yeah. So I am done. We were tuning instruments, and then we were tuning the instrument that tunes the instruments. But I gotta run. I gotta walk my dog. So things are crazy around here. I will hopefully be streaming tomorrow. No promises. The end card I did not do yet. I need to just do that quickly. Let's just do the end card here. Over to admin, and I just copy paste it. Copy, paste it, and then figure out what day it is. What day is it? And we'll just put 24 in there, but no promises. Okay, 24. Hit enter, and now I can use the command to tell you guys all my social medias and stuff. If I could find the chat window, there it is. So no promises about tomorrow, but I would like to stream. We'll see if we can get around to it, and then we can chase these 9s and actually get this stuff to work. We're getting there. We're getting through the modular synthesizer stuff. And then next week, Burn the Subs desperately needs my attention. So I will pull the table out so that I can get back there and we can work on it a little bit. We got to do some wiring stuff. I'll see you guys then.
till then, I'll be on Discord and just generally bumming around. And I'll catch you guys later. Have a good one.